Good morning. There you go. Excellent. Well, my name is Arun Gupta. I work for Red Hat. That's quite evident. I work for Red Hat. And
I'm Peter Moskowitz, and I work for Kazing.
All right. So we are here to talk about WebSocket. This university session is about nuts and bolts of WebSocket. We intend to cover what WebSockets are, what are they good for, and hopefully show some tweaks that you can do to make it better in your life. Right? You can see at the bottom in the footer, these are the two hashtags, so #DevOps and #WebSocket. I got a tweet page open on my browser. Feel free to ask any questions using those two hashtags. We're watching those two hashtags. Every 15 minutes, 30 minutes, depending upon the traffic, we'll take a look at those two hashtags and see if there are any questions. If you want to ask questions by any point of time, ask questions. There's a microphone over here, so reach out to that place and ask questions. Otherwise, if you yell, and then I may have to repeat the question in that case. We both have Twitter handle, so here is mine, and on the bottom is what Peter's is. Okay, let's get started. So in terms of the agenda, this is what we intend to cover today. We talk about introduction, what are WebSockets basically, then show you how you can easily create a simple Node.js application and run your very simple WebSocket application over that. We'll talk a lot about JSR 356. That's a standard way for building your WebSocket applications in the Java platform. We'll talk about a lot of that. Then we'll talk about securing WebSocket, embedded WebSocket, load balancing WebSockets. This is the nuts and bolts. Anyway, lots of pub/sub over WebSocket, different messaging protocols. So we'll talk about Stomp, MQTT, and we got some nice toys to show you on how WebSockets operate over there. A little bit of comparison between REST and server-sent event, of course, with WebSocket. So how is WebSocket compared with REST? WebSocket comparison with server-sent events. We'll show some data points on that. Talk a little bit about what makes WebSockets scalable. Some debugging and some production tips as well. So lots of content today in about 3 hours. Feel free to keep it interactive. We are thinking somewhere around securing WebSocket, a little bit before that is where we will take a break. That's where half the timeline. And we'll take like a 10-15 minute break and then resume back and then go all the way up until pretty much 12:30.
Sounds very good.
All right.
Did you want to say a few words about our roles, what we do?
Sure.
Maybe I can do it very quickly, and then you can go on. So Kazing is a company based in California, in the Silicon Valley, and had a very significant amount of contribution to the WebSocket standard. And Kazing has an enterprise-grade WebSocket server that is deployed across the board in many verticals. At Kazing, my role is head of real-time solutions, and my job is to show people like you, developers, architects, what it takes to build real-life applications using this relatively new technology. My job is also to build solutions and demonstrations and ignite people's imagination about the possibilities of the technology. So I brought a handful of demos, both web-related demos as well as physical IoT-related demos that we are planning to show to you guys live.
Yeah, and at Red Hat, I'm the director for developer advocacy. So as part of that, I'm responsible for all of JBoss middleware at Red Hat and then their developer outreach efforts. I've been presenting at conferences all around the world for many years now. And WebSocket is something that I've thoroughly enjoyed for the past couple of years. And this is a brand new presentation that I've built, Peter and I have built together. And we are excited to share from the technology perspective, from the production perspective, kind of brings a unique combination to make it exciting for you guys. So tell us about WebSocket. So I'm going to switch to PowerPoint here.
So we figured we would kick off with a story, with a bedtime story. And let's start at the very beginning of this. Here we go. So this is a story about a parallel universe. A parallel universe that is identical to the one that we live in, with one exception. The Postal Service does not have a notion of a mailman. But mail is very important to you. You want to know when you have mail. So you're at home, you dropped off the kids at work or at school, and you're ready to get some stuff done, and you realize that maybe there is mail for you. So what do? You get in your car and you drive to the post office. You check if there is any mail for you. Well, there is no mail right now, so you hop back into your car and get back home. You get some work done, and around lunchtime, you realize that maybe there is mail for me now. So you hop in your car and you drive to the post office. You check if there is mail. Nope, no mail for you. So you sit back in your car and go back to work. You're very effective in the afternoon, but around 5, right around the time when the post office is about to close, you realize maybe one last time I want to check if there is mail for me. So you drive to the post office and you see if there is mail for you. Well, there is no mail, so you drive back home. Now, with this method, there are many, many problems. First of all, when you leave, you have no idea if there is going to be mail for you. You just go there to find out. While you are driving, you are polluting the air, you are causing traffic congestion. So there's a lot of challenges with this. But this was so common in this parallel universe, this method of checking mail, that they even came up with a name for it. They called it polling. And they kept polling over and over again for years and years. But then, they were very bright in this parallel universe. They realized that maybe there's a better way to deal with this. You have grandma at home. And grandma is not doing a lot around the house, so maybe there's a better way to utilize grandma. So you ask grandma to hop in the car in the morning and drive to the post office. And instead of grandma driving home after it turns out there is no mail, grandma decides to hang out around the post office. Grandma is spending time there. She's there in the morning, she's there at noon, and eventually some mail arrives. So grandma becomes very happy about it. She picks up the mail, she jumps up and down, jumps back into the car, and drives back home. She drops off the mail, and right after dropping off the mail, she hops back in the car and drives back to the post office to be ready for the next mail whenever that arrives. She hangs out at the post office as usual, and then eventually, as the post office closes, as the time comes, she hops back into the car and drives back home. Now, this is a lot better than what we were doing before, but it's still not perfect. First of all, what if there are 2 mails that arrive back to back? Grandma picks up the first one, drives home, drives back to the post office, and then she has to pick up the second one and drive back home and pick up and drop off the second mail. Also, grandma is still polluting the air. Grandma is still causing traffic congestion. But this was so common after a while in this universe that came up with a name for it. Given that grandma was spending long days at the post office, they came up with a name for it, long polling. Now, long polling was very, very good. It was so popular that actually as the village started to grow, more and more families decided that they send their grandma to the post office. So grandma started hanging out around the post office. And eventually, the post office had to introduce new counters and even new offices to deal with all the grandma's long polling at the post office. Not only did they have to build these new post offices, but they also had to build new parking lots for all the cars. So it went like this for a very, very long time. Until, on one day, in this parallel universe, they came up with a brilliant idea. And that brilliant idea was the notion of a mailman. The mailman was the one who took all the mail and delivered it to your house. You did not have to worry about polling or long polling for the mail. You were sitting at home idle, not doing anything. You were there focusing on your work. And eventually, when the mailman came, the mailman rang the bell, you opened the door. If needed, you signed on the dotted line for certified mail, and you received your message. So our hope is that parts of this story may ring the bell to you. We are here to talk about some of these challenges and how the technology addresses these challenges.
All right, so I hope you're not using, you're not going to post office regularly. I hope you're making better use of your grandmas, and let's rely upon the mailman actually to deliver the post. So with that, we'll see, what sort of what use cases does WebSocket really solve? So HTTP was designed many, many years ago, and as part of that, the main goal was to share data across network, literally across ARPANET. But when it was created, when it was designed many years ago, it served the purpose really well. But now, over a period of years, we have figured out some limitations, so to say, for HTTP. So the first one is client-driven protocol, in the sense there's a client, HTTP client, be a browser or API, whatever it is, and then there's a server, HTTP server. So the client has to make a request to the server then processes the response, and then it goes back. There is nothing for a server to say, hey, you know what, I need to send some data to the client and send it data back to the client. That's not possible. Second is, it's a half duplex protocol. That means at a given point of time, client can send data to server, and server can send data to client. They both cannot talk to each other at a given point of time. At a given point, only one party can communicate with the other one. So it's a half duplex protocol. It's a very chatty protocol. We'll see that in a second. There are a lot of HTTP headers for a simple hello world that needs to go back and forth from client to server and server to client. So there's a lot of communication that's happening. That's okay to begin with when you have few messages per second, but it quickly becomes a bottleneck when you have lots of messages going back and forth over the wire. And the biggest problem typically with HTTP is when you are starting a new HTTP connection, underneath the network layer, start a new TCP connection. So for every HTTP connection, a new TCP connection gets started, you receive a response, and the TCP connection goes away. For a new WebSocket connection, it's a new TCP connection altogether all over again. So these are so-called some of the limitations of HTTP. Let's see how WebSockets take care of them. But before that, this is sort of a dump of how many headers are being exchanged between client and server. The specification itself requires a few headers, but HTTP, either a browser or a client or an extension in the browser, they sent a whole bunch of headers. Similarly, a server like WildFly or any other server would send a whole bunch of headers to make sure HTTP processing goes through. So for a simple hello world, these are about 663 bytes. 11 bytes of hello world, 663 bytes of overhead, just for a simple hello world. Okay. So how WebSocket solves it? Well, first of all, WebSocket is a bidirectional protocol. That means client can talk to server, and server can talk to client, as opposed to client-driven in case of HTTP. Second is, it's a full duplex protocol. What that means is the client and server can talk to each other independent of each other. Now, they don't have to really wait. There are no predefined design patterns that you send a request and I send a response back. If you go back to the SOAP analogy or a WSDL analogy, it's a one-way message. Client send a message to a server send a message to a client, independent of each other. It's a very lean protocol, and I will show that exactly in a few slides. There is a very little overhead in terms of the protocol, the way it's being defined, on how much amount of data that goes over the wire. And then the best part about WebSocket being, you start with a simple HTTP connection, and then you upgrade that. That's a standard HTTP terminology. Using a simple HTTP connection, you upgrade it to a WebSocket connection, and that TCP connection is held on to. And then on that TCP connection, the client and the server truly becomes peers. And now they're exchanging unlimited data between client and server until one of the parties says, I don't want to talk anymore, and then they close the connection. Okay? So with that, my one-line definition of WebSocket really is, it's a bidirectional, full duplex communication channel over a single TCP connection. We emphasize upon each part of that in the previous slide. It was originally proposed as part of HTML5, which fortunately became a full standard last month. But WebSocket itself was defined as a standard in December of 2011, so about 3 years ago. So if you want to learn more about the protocol itself, then you can Google for the number RFC 6455. It's not a huge, extensive document. It's a sort of a medium-sized document per HTTP or IETF standards, but it defines how the protocol looks like, how on-the-wire should look like, how packaging, framing should look like on the wire. So that's a nice document to read through. And then the second part of WebSocket people generally talk about is a JavaScript API, which is again W3C defined. So this is a JavaScript API that's you're going to use in your web applications or in your browsers if you want to call a WebSocket. And we'll take a look at both of those in detail. So how does it work? Well, using standard HTTP terminology, you take an existing HTTP connection, you upgrade it to WebSocket, a single TCP connection stays there. Then you send data frames back and forth in both directions. Client is sending messages to server, which is basically translated to WebSocket frames. That's the terminology that is used in RFC 6455. So you send frames from client to server or messages. Similarly, you send messages from server to client, which are then translated to WebSocket frames on the wire. The messages are independent of each other from client and server, so that makes it full duplex. And you end the connection. Okay? Picture is worth 1,000 words, so let's take a look at it. Now there's a client and a server. They're happily communicating HTTP, the exchange HTTP connection, new TCP connection established, TCP goes away, new HTTP, new TCP. At a given HTTP connection, they say, or rather a given HTTP connection, they would say, I want to make a WebSocket connection. So that initiates what they call as a handshake request. Now how the handshake request looks is defined in RFC 6455. So this is basically a set of HTTP headers that goes over the wire. If a server understands the handshake request, it responds back with a handshake response. Okay? Let's take a look at handshake request and response. So this is the sort of example set of HTTP headers that goes over the wire when it's a handshake request. So as you can see, it's just only a HTTP headers. There is no payload that goes as part of it. So in this case, I'm saying get/chat HTTP 1.1. So this is the URI that I'm invoking. It has a host. Basically, the client and the server agree upon which host they're talking to. Upgrade WebSocket and connection upgrade. Those are the two headers that are required as is to initiate a WebSocket handshake request. You know, those headers are generated by your underlying stack on the client side, so to say. The request is always initiated from the client side to the server. So that request initiation is from the client side in that sense. Once the upgrade and the connection headers are included, in addition, you also specify some sec WebSocket headers. Now these sec WebSocket headers are again generated by the underlying WebSocket implementation. These are not something, these HTTP headers. So for example, you can use XML HTTP request to generate a set of HTTP headers. You cannot generate sec WebSocket headers over there. If you try to generate it, it just ignores it or even throws an error in certain implementations. So these headers must be generated by the underlying browser implementations. So there are like a few, so in that sense, how these headers look like and where these headers are generated are really done by a few key people like a Chrome browser or Firefox, and implementations like that only can generate them. But this is the set of HTTP headers that is required part of handshake request. And then on the server side, the HTTP headers that are sent back are called as handshake response. The key part being, at that point, the server is switching the protocols, is saying HTTP 1.1 switching protocols. 101 is the status code, and switching protocols is a message over there. It echoes the response back to the server or to the client that, okay, I'm going to upgrade your connection to WebSocket. In addition, it also sends you sec WebSocket accept key. Or at the header, where it really takes the sec WebSocket key, which was sent as part of the request, applies an algorithm to it, and generates the sec WebSocket accept and send it back. That's what basically says, okay, the protocol handshake is now complete. With that, once the handshake is complete, the client and the server are then engaged. At that point of time, the client and the server really become true peer. That means they both have same capabilities. The amount of messages that they can send, the APIs that they can invoke is very much similar. So let's take a look at it in a little bit more detail. Now there's a client peer and a server peer. There are callback handlers on the client side and on the server side. Oh, the connection is open. So onOpen is being called on both the sides. Okay. The server now tries to send a message. So there's an onMessage callback handler that could be called on the client side. Server tries to send another message. So again, an all-message callback handler. Important part to realize here is there is nothing initiated from the client side to send a message. it's a one-way message. Server sends a message. How you correlate it, and what language you use is completely independent for you. WebSocket by nature is a stateful protocol. So the TCP connection underlying is connected, it stays open. The state is maintained both on the client and server side. Okay, when the client tries to send a message to the server, maybe the message doesn't go through. So in which case, an on-error callback handler is called on the server side. Finally, client is able to send a message to the server, so on-message callback handler is called. And then the server may initiate, okay, let's terminate the connection, we are done talking, in which case an on-close callback handler is called. And at that point of time, either party can initiate the connection closing, and at that point of time, the connection is terminated, and the TCP connection goes away as well. But between the green arrow and the red arrow here, the number of messages that can be exchanged, there is no limit to that really, at least practical or hypothetical limit. Another important aspect to understand about WebSocket, which is not very heavily used, is called as subprotocols. One of the headers that goes as part of handshake request is called a subprotocol. Now, WebSocket is a very low-level protocol where literally is socket on the web. What's the payload? What else is going to go on that? It's completely up to you. So that's where these WebSocket subprotocols facilitates application layer protocols. You can have these subprotocols registered as part of a standard naming registry. You need to define certain fields as part of the naming registry. You can use predefined protocols. So, for example, there is STOMP. We'll talk about that a little bit. There is XMPP, MQTT, SOAP. There are all these different subprotocols that are defined. So that's one way where you use a predefined subprotocol. And when I say predefined subprotocol, what that means is the payload over the wire, because eventually it's a socket on the web. And as part of WebSocket, you're sending payload. What the payload should look like is defined as part of the subprotocols. But again, this is a very niche topic, not used pretty heavily. The other little bit niche topic that I'm going to talk about is WebSocket extensions. And literally, there is just one slide on it, because again, it's not very heavily used. But it basically adds capabilities to the base protocol itself. Things like multiplexing, or you want to do compression, whether per frame, which is like a WebSocket message, or per message. And there are IETF drafts that are defined on how you can actually get started with those. But there are not a lot of implementations, and there is interoperability issues around subprotocols and extensions that way. So let's take a look at my JavaScript API. At the bottom of the screen, you can see the URL where you can get all the details about the WebSocket API. If I were to read this API, so here I'll say, when I'm creating this WebSocket API, I can specify the URL, which is where my WebSocket endpoint is listening. And then optionally, I can specify what subprotocols I want to talk about. Okay? So my URL is available over here. There are certain ready state variables over here. You can define buffered amount, which is basically how much amount to buffer before sending the network data over the network. Then there are certain callback handlers. We talked about on open, on error, on close. So those are my 3 callback handlers that are defined in the JavaScript API. Now, this is the API that you will use typically as part of your web application, and you will define those callback handlers, and we'll see several of those. This is my close method over here. And at the bottom here are my 4 messaging methods, which are my basically send message. So WebSocket can send a text data or a binary data, and all are sent using the send method. If I'm sending text, then that goes as text. And if I'm sending binary, then there are 3 different ways to do that. So either blob, which is a default type, or array buffer and array buffer view. And what is the type of the binary is being defined using the binary type here. So you can say WebSocket.binary type array buffer, and then everything is going over the wire as array buffer. Okay? Now, because you're using JavaScript API, an important part is which browsers actually are supporting WebSockets in that sense. Let me ask a fun question. How many of you, and raise your hand big, okay, I want to see hand big. How many of you are using Internet Explorer as your primary browser? 1, 2, 3, 4, 5. And I understand that's because of corporate policy, so I totally get it. And the reason I say that is, well, Internet Explorer has maintained a very good market. And the reason it has maintained good market is because it is not supporting WebSocket until IE 9 and before. and IE 6, 7, 8 are still prominent browsers in a corporate deployment. So, I mean, if you look at this, you go to this website, caniuse.com/WebSockets. It shows you which browsers are supporting WebSockets for how long. So if you're going live with your application which supports WebSockets or using WebSockets, then you need to be aware of this. So in this case, IE 9 and before has not supported WebSocket. The modern browsers, so Firefox, Chrome, Safari, all three have been supporting for a while. And then there are other mobile browsers. It also shows you how much US market share and the global market share is there for WebSocket. This is a neat website to be aware of, if you're going production with your applications. All right, so with that, we're gonna get started. We're gonna show our first simple sample. So I got, few questions here. It's becoming more seriously suddenly, okay? My work is hard, yeah. Nice polling story, it started. Okay, all right, no questions so far. Not bad. So what I'm going to do is I'm going to go to this website, websocket.org, echo.html. Now this is a this is a site hosted by Cousin. Very simple way to get started with it is, when you are making a WebSocket connection, you use the protocol ws:// as opposed to http://. That's a new URI scheme that is required when you're making a WebSocket connection. So effectively from your application, you could say new WebSocket ws://. The moment you say that, it automatically triggers a HTTP handshake upgrade. So this is the WebSocket endpoint that I'm going to listen to. So I connect here, and it says connected. I'm going to send a message, and I get a response back. This is a simple echo endpoint. But remember, when the messages are going back and forth, this is a request message and a response message, all right? So let me disconnect here. Another way to deal with this is I can go to, say, Chrome Developer Tools. Okay. Now if I go to my console, so here I can say, for example, ws equals new WebSocket, and I can copy this URL. So here you go. I just created my new WebSocket connection using Chrome Developer Tools. So if you know an endpoint where WebSocket is hosted, so you can see your WebSocket endpoint here. It shows you the URL. The binary top by default, as I said, is blob. My on, close, on, error, on message, all these callback handlers are null. The URL is over here. I don't know why is it showing 2 times. So now I can say WebSocket dot say on open or on message. So every time I receive a message, I want to do something here. So I can define a function here. And I can say, okay, I just defined a new function over there. So now, if I say, hello world, I'm sending a hello world, and on message, I'm just doing an alert, and that alert is shown to me over here. So without even creating an application, it's a very easy way to take a look at it, how your WebSocket connection is getting established. You can see the other part that I want to show you here is, so if you go to Network tab here, by default, I can filter over here, and I can say, show me only the WebSocket connections. And here you go. So this is my WebSocket connection. So in here, I'm seeing my HTTP headers. So the protocol handshake has been accepted over here. This is my upgrade. And this is my connection header over here. In the response, you can see there's a bunch of access control allow headers. And we'll talk about that a little bit later when we talk about cross-origin request sharing. But then I have an upgrade and a connection header once again over here. And then on this tab, I can see the request, the actual WebSocket frames that are being exchanged back and forth. So you can see hello world was being sent, and hello world is the one that is being received. So without creating any WebSocket server, any WebSocket client, literally from within my web browser, I can say, hey, by the way, just go make a WebSocket connection and come back here. An important part to understand here is I am on websocket.org/ So I can actually connect to it from the Chrome developer tools. If I'm on a different domain and from the Chrome developer tools and I say, okay, now connect to it, that won't work because it's from a different origin. So that part is important to understand, and we'll talk a little bit more about that a little bit later. Another part I want to share with you, my entire transcript of what I'm showing today. Of course, the slides would be available, the recording is being done, but everything that I'm showing today in the lab is available on this GitHub repo. So github.com/arun-gupta, nuts and bolts of WebSocket. So this is a script that I'm going to be following today, building along, what are the fun things that we can do with very easily. Okay? So now we have shown a simple websocket.org, simple Chrome developer tools, connecting to it, verifying my messages, seeing my developer tools, network frames, WebSocket frames, all of that. Let me show you how easy it is to get started with doing a simple WebSocket application using, say, Node.js. Okay? So if I move along here, so these are the parts that we have covered so far. Now, we talked about Chrome developer tools, but if you're using Firefox, there is similar to Firefox developer tools there as well, which has similar capabilities. So by no means I'm restricting to Chrome, but that's the one that I use a lot more common. Another part important to understand is, just like you need an HTTP server, you need a WebSocket server. Or your server needs to support WebSocket capabilities, because otherwise the protocol handshake request and response won't be accepted. So don't assume that your Apache understands WebSocket requests. That's a very important concept. You need to have a backend server like a WildFly or a Cousin Gateway or something like that, which understands your request and response, and which says, okay, I receive a request and I know how to respond back to that, which means generating your sec WebSocket keys back in the response, and the client says, connection established. So now for Node.js, what I'm going to do is I'm going to spin up a simple instance of Node.js. Now OpenShift is Red Hat's open source cloud platform. I won't talk too much about OpenShift here, but effectively I'm going to log in there. Anybody can log in to or sign up to OpenShift. You get free applications, no time bombing over there. You get 3 free gears over there, and each gear is half a gig of memory and a 1 gig of disk space. Okay, this is a corporate account, so I got a little bit more capacity here. But effectively, what I'm going to do is I just want to create a new application. So I say add application, then I search on keyword here, say Node.js, and I want to create a Node.js instance on the cloud. I just choose the default name, Node.js, take everything default, and I say create application. So what it's going to do is, oh, the name is already there. So let's do Node.js 2. So it's going to provision a Node.js instance for me in OpenShift. It's all backed by Git. It's going to show me a pointer to my Git repository, and that way I can clone the Git repo on my local machine and play around with it locally. And the model with OpenShift is, you have your Git repo, you can commit, and when you push to the remote repo, as soon as you push to the remote repo, your application is live right away. So very clean programming model, and there is a lot of integration with developer tools. Eclipse, IntelliJ provide very good support for it. And now, so literally, in about less than 30 seconds, my Node instance is provisioned on the cloud automatically. So I can go to the application overview page. I can say, this is my Git repo. I'm going to copy it. Yeah, so this is a clean directory for me. I'm going to do git clone here. Okay, so I just clone my repo. So here is my Node.js 2 application. Okay, all I'm going to do is go back to my GitHub here. I have written a simple server here. Okay, it's a simple JavaScript. All I do is I create a simple HTTP server. It requires a WebSocket package. I receive a request and a response back. Okay, so I'm going to copy it here, and I'm going to open up my server.js in my Git repo. I'm going to delete everything, and I'm going to replace it with this. Okay. All right, so we just saved the file over there. And then in addition, if you look back at the Git repo, I need to install the package here. If a node instance is provisioned on OpenShift, you already have the WebSocket package included in there. But in this case, I will have to provision it myself. So I'm just going to say, well, you do need a local instance of npm as well, but I'm going to install this package here locally in this particular Git repo. So this is installed, and then all I'm going to do is I'm going to git add everything. I'm going to commit everything, and I'm going to push now. So I'm going to push it, and as soon as I push, all the changes goes back in my Git repo, and my Node.js particular instance, as you can see, is restarting my node instance. Preparing the build for deployment. In a few more seconds, it's going to be activating the deployment. Well, it's already activating a deployment, and my instance is live. So now, if I go here, and I say, show me my application, this is the application page. That is what we created from server.js. So if I look at it here, for example, so all I'm doing is I'm logging in here. Welcome to Node.js on OpenShift. This is the message that we are logging ourselves. Okay. Now, an important part to understand here is when WebSocket are deployed on OpenShift because of some weird routing problems, one of the advantages of WebSocket is you can go back to port 8080 or 80, whatever is open, and that works out of the box. But because of some weird routing problems on OpenShift, WebSockets are exposed on a different port, which is 8000 for now. The next version is planning to fix it, but for now, WebSockets are open on a different port. So what I'm going to do is I'm going to go back here, and in here, all I'll say is Node.js2 is my application name. My domain name is miles2go, and the full address is rhcloud.com. Okay, so I'm going to connect to this endpoint, and it did not connect. Oh, 8000. No, this is Node.js. Well, this is application name dash domain name. So that's the whole thing. So now when I connect it, so now it's connected. So it says connected, response is welcome. And this is my Node.js, my WebSocket endpoint running on Node.js. So very clean. Now I send it, and I get a response back. So again, a very simple echo endpoint hosted on Node.js running in your OpenShift instance. So you can really start it up very quickly, literally in a matter of a few minutes. If you have never signed up for OpenShift, go to openshift.com, sign up for an account, provision an Node.js instance over there, and use websocket.org to test it out, or Chrome developer tools for that sake. Okay, that works very well. Okay, we did that. All right, so we're going to switch gears. Now we're going to talk about Java API for WebSocket. Any questions so far? Well, I'm going to switch to the Twitter screen for a second. Okay. Only 5 developers use Internet Explorer. Yeah, that's sort of my persistent feedback I've heard all along. All right, we'll keep going then. So Java API for WebSocket. Now, Java API for WebSocket was designed as JSR 356 as part of the Java EE 7 platform. It basically provides you a standard API by which you can write WebSocket-driven applications on the client and the server side in the Java language. Okay, there are 2 primary ways. You can do an annotated endpoint, where you can take a POJO, put annotations on it, and that becomes your WebSocket server endpoint or client endpoint. Or you can say, I want a little bit more knobs and dials, in which case you go for a programmatic endpoint. And I'm going to show several samples. It's a lot of code-intensive slides, so you'll see a lot of code throughout the slides. The advantage of going with a programmatic endpoint is where you have more control over handshake. You know the underlying HTTP headers that are being exchanged, and you can manipulate them or have access to them and things like that. Just like you have lifecycle callback methods on the client side, you have them on the server side as well. Those are, again, annotations. And of course, this is part of Java EE technology, so there's a very nice integration with the rest of the Java EE technologies, which we'll show in the talk as well. So here is my simple canonical hello world example. If you look at the black part of the code only, so all I'm saying is public class hello bean, simple method, take a parameter, return hello plus name, okay? Just that. Now that's a very natural Java program. There are no artificial constraints here, no implements, no extends. Just by putting at server endpoint annotation, I published this, just that single class and a single annotation makes this as a WebSocket endpoint. And here is a URI where the WebSocket endpoint is listening. Now, of course, a WebSocket endpoint, this is a server endpoint, so it's listening for a request from a client, and in which case, it needs to call a business method every time it receives a request. And that's where you say, oh, dispatch this business method with @onMessage. And it takes a string parameter. That means this endpoint is going to receive a text payload. I'm going to take the text payload, put that into the string parameter, and the fact that I'm returning a string value here, that means the client is going to receive a string payload, and the server is going to return a string payload as well. Return is a terminology in case of Java, but just by using normal Java programming language paradigm, you're able to do a request-response design pattern on WebSocket. So see, it's very natural in that sense. If you're using a normal Java program, just by that fact, you're able to correlate your request and response messages very easily. But on the wire, these are two independent methods, or two independent messages from client to server and server to client. So in terms of class level annotations, there are two class level annotations. There is a server endpoint, which of course takes a POJO, converts it into a server endpoint. And there's a client endpoint annotation, which makes a POJO into a client endpoint. A typical WebSocket topology is, it's like a wheel topology. You have a server at the center, and the clients are all on edge of the wheel. So a client is sending a request to a server, and then the server has the capability to broadcast to all the clients. If a client has to talk to another client, they have to talk through the server. So it's always an edge, server at the center and clients all around the edge of the wheel. There are method level annotations. These are basically my callback handlers. So on message, on open, on close, on error. And each of these annotations take slightly different variations. So for example, if you're doing on open, it'll give you a session parameter. It's a very overloaded term, but session is basically a conversation between client and a server, which gives you more detail about the client endpoint and the server endpoint. And then you can look more into it. If there's an on error, then it's going to give you a throwable, for example. Oh, what could have caused the error? Give me more details about the error itself. And then there is a concept like parameter level annotation. So you can have, just like in the REST world, you can have a variable template URI and have a piece of that match to a segment or to a method parameter. And we'll see samples of that as well. So look at a little bit about server endpoint attributes here. So value is a URI where your endpoint is listening. Now, your server endpoint is always receiving text or binary data. You may not want to deal with raw data every time. So in which case you may say, hey, by the way, receiving the data is okay, but I want to deal with my business domain object. So in which case you define decoder, which basically says, oh, I'm going to take the string and I'm going to decode it to a POJO. Similarly, you can define an encoder. You can say, because on the wire what goes is text or binary. So in that case you say, I'm going to take a POJO and I'm going to encode it to string or binary. So you can define a bunch of encoders and decoders, which is basically following your dry principle, don't repeat your code. You define your encoding and decoding mechanism in one class and specify them as attributes on your different server endpoint annotation. And you can of course define subprotocols, which basically says which this particular endpoint is going to accept so-and-so subprotocols. Here is my canonical chat server. So I have a public class chat bean, and I'm saying to convert this into a WebSocket server endpoint, I just say add server endpoint annotation. This is a URI where the endpoint is listening. These are my on open, on close callback handlers, just regular business methods with @on open, @on close annotation. When I'm opening, then I get a session parameter. When I'm closing, I get a session parameter. And on the server, because it's a stateful protocol, I'm maintaining a static set of sessions. On open, I add that to the set. On close, I remove it from the set. And when a message is or a payload is being sent to the server, all I'm doing is I'm going through the set and broadcasting the message to the server, all the clients. Okay? So it's a very canonical chat server, but it definitely can be further simplified, which is like this. It's a very common design pattern that the server would need to know what all clients are being connected. So in this case, all you're saying is, so here you're just sending the payload. On this, you are sending an additional optional parameter called as session endpoint, which gives you more detail about the client and the server that are chatting with each other or exchanging messages with each other. So because this is an object that handles both client and server state, you can say from the server, you give me the all open sessions, and then you broadcast the message. So these 9 lines are really your canonical chat server in a single class that works out of the box. No deployment descriptors, nothing. So very simple. All right, let me show you a simple deployment of that. So if you guys are not familiar with it, I'm going to show something here. These are a ton of Java EE 7 samples that are contributed by about 40 contributors. I started this about 2 years ago in order to learn technology, but over past year I've dealt very little with it, but a lot of people from outside the community have contributed samples to it. These are about 200 plus samples and tests that run very well if you want to understand Java EE 7 technology. But if you look at WebSocket, for example, and that's the one that we were looking here, is there are about 30 plus samples highlighting different aspects of Java EE 7 WebSocket API, so which is very useful. The one particular sample that we are looking at right now is a chat sample. Okay, so if I look at it, and then I can understand this myself. Once again, what I'm going to do is I'm going to go back to, say, my OpenShift here. I'm going to log in, and I am going to create I'm going to provision a WildFly instance here. Okay, so I'm going to go down, and here is my WildFly instance. So I'm going to call it as chat server. Okay, and I'm going to create an application here. So once again, it's going on OpenShift. It's running on a bunch of RHEL servers. It provisions my gear. It downloads WildFly server. It provisions my WildFly server over there. Now, WildFly is a Java EE 7 compliant server, so any of the Java EE 7 APIs are supported over there, which includes WebSocket. So what I'm going to show you is how easy it is to create a simple application and deploy it on WildFly running on OpenShift. In this case, it's going to be a chat server. So the idea is, if you guys have your laptops open, anybody can join that chat server, and we can communicate messages over there. Okay. In the meanwhile, so here, so I'm in the Java EE 7 samples. Let's go to WebSocket. Let's go to chat. Let me open up the source code. For a second, let me change the port to actually 8000. Okay, so I do that. Host port, everything else looks good. Okay, so all I'm going to do is I'm going to build this thing again. So here is still creating my WildFly application. And let me fire up my IDE in the meanwhile so that I can show you the source code behind this. Okay, it's still creating my WildFly instance. So my war file is ready here. If I go to target, okay, that's my war file. So while it's still provisioning my WildFly instance, let me show you the code in the background here. So here is my source package. Here is my simple chat endpoint server. And as I said earlier, this is the endpoint it's listening at. This is a simple message. This is the client. And then all I'm saying is I mean, the variable is called as client. It can really be called server client. But on the server side, on line 17 particularly, I'm saying give me all the sessions, and I'm broadcasting the message. Now on the page, the web page, here I have my usual text area, text boxes, and then I have a join and a send message method. And if I look at my WebSocket script here, in here I'm saying a ws:// host port. Because I'm testing this on OpenShift, I need to change my port to 8000. Line second, it says new WebSocket URI. The moment I start new WebSocket, that's the time I'm actually making a connection to the backend server and my protocol handshake request and response kickstart. I'm setting up my onOpen, onMessage, onError callback handlers here. These are my simple join and send message methods, which are called from the page. But underlying, it's using simple WebSocket.send API. They just have different semantics, but the syntax is exactly the same. Okay, and my WildFly instance is here. Now I go to the application overview page. If I open up this page here, so this is my default WildFly page on OpenShift. Here is once again my Git repo. Okay, so if I go back here, I come to my WebSocket talk, and here I just clone the Git repo. Once I clone my Git repo, it's going to check out everything that is generated by default as part of the Git repo, the WildFly application. So here I come to my chat server. I can just remove, say, source and pom.xml, because that's what is generating the default page here on the application. So I can get rid of that. And then if I look at my deployment directory here, which is target directory over here, I can say copy my chat.war file here into deployments and call it as root.war, and there you go. Okay, and now I can add the directory, and if we look at git status, this is a new file. All these files are deleted over here. I commit and I push. All right, so with this push, now everything is being pushed on the WildFly repo, and it's going to just restart my cartridge. And this chat server is basically available for anybody to join. So it's still starting up my app server. I mean, still starting up my WildFly cartridge here. You can customize it where you can say, oh, do not start the cartridge and things like that. I mean, I could have easily deployed this sample locally on my machine, but this allows you to simplify your development because everything is being handled on the cloud for you. And more importantly, you can share the URL very easily with somebody else as well. So now if I go here, chat server, miles to go, here you go. So it's connected to my endpoint. Oh, there you go. Somebody already joined. So, bum. Okay. So if I join here, I can see here. Okay. So if I open it in another window here, of course, this is not maintaining state. So you can see people are joining and the list is growing fast. The interface, you can see I'm graphically challenged. This button is whatever is entered in the text is for joining. And the same button, whatever you enter in the text here, it can say for chatting as well. But the idea is, you see what's happening in the background. Now in here, if I open up my network tab here, I need to reload the page and I can filter. Can we break this? Try it. And here I am in WebSocket and I can see my frames being exchanged over here. Okay, and that's the whole advantage. There's a little bit of interaction here. We can see some fun messages happening over here. And this thing is going crazy. Okay, that's fun. All right, so you get an idea. These are all connected to a simple WildFly server running on the cloud. If I was running on my local machine, then this interaction was not possible. Okay, keep trying to break it. I'll go back to my presentation in the meanwhile. All right, keep going. So we talked about how simple text messages can be exchanged. Let me talk a little bit about encoders and decoders now. So we talked about how it uses the dry principle to encapsulate your design patterns, decode from text to POJO, and encode from POJO to binary or text, whatever you want. Let's take a look at how those encoders and decoders are defined. So my message decoder, it says decoder.text, and it works on a type my message. It takes a string and decodes it to my message. So these are the two. This is one method that you need to implement. There is another method which says will decode, because potentially in your server endpoint you could have multiple decoders. So one of the methods only need to claim that it can decode the message, others need to return false. So the intended thought process is you peek into the message, you figure out whether you can decode or not, and then you return back true or false accordingly. Similarly, you have an encoder which takes a my message and it encodes into a string, because remember I said on the wire what goes is string or binary or byte buffer. Similarly, you could have binary here. So let's see how my method signatures really look like. Well, in terms of method signature, I need to have a text payload, a binary payload. Okay. In terms of text, I could have string, any Java primitive type, it's automatically converted to the Java primitive type, or reader, for that sake, if you want to read in a streaming fashion. In terms of binary, you can have byte array, byte buffer, byte array and a boolean. That means you're receiving in chunks, byte buffer and boolean, or an input stream. So either way, reader or input stream would work. And then there's a ping pong messages which are defined in the protocol where you can keep your connection alive. And so you need to handle pong message, because server could send a pong message, in which case the client needs to be able to handle it. You can have an optional session parameter, which gives you more detail between the client and server communication. And then you can have additional whole bunch of string parameters, which allows you to map the variable part of the template. Okay. So my sample message in that case, method name does not matter. All that matters is the @on message annotation. So I have a string, simple string payload. I could have a float, in which case a string payload is converted to float, and I have a variable path parameter here using the @path param annotation. I could take a reader, and in this case, I'm getting more details about my session, which is between client and server. For byte array, or for byte payload, I can say byte array or byte buffer. Or I can have a little bit more elaborate method, string payload mapped to integer, session giving me more detail about the client and server communication, and I have a couple of path parameters over here. All right? Let me show another sample on how these encoders and decoders work. I'm going to show you an application running on two different browsers, Chrome and a Firefox. And we can again try to deploy this on the cloud, because we have the instance provisioned already. But the idea here is, whenever I click on a particular browser, the same thing is being, it's like a collaborative whiteboard. Whenever I click on a browser, everything gets shown up on the other browser. So you keep doing it, you keep changing color, shape, and that gets reflected. Okay? And this is again one of the whiteboard samples on the Java E7 samples repository. Okay, so this is where I go. I go to whiteboard, and in whiteboard, if I open up my WebSocket script here, I'll walk you through it. But for now, let me change the port. Okay, just that. Then I go to my whiteboard, and then I say Maven clean package, and I build the bundle. All right, so here we go. So this is my target directory. Okay. So now I pick it again. Okay, so take my whiteboard.var and put it on deployments as root.var. Okay, so if you look at git status here, that's the only one changed. Git I always confuse with one single dash, double dash, all A. Just define aliases for them. So now I'm gonna say commit from devox doc. Okay, don't start hitting the server right now. I'm going to show the sample first, then you can start hitting the server. Because I haven't tested it in that environment yet. Oh. Okay. So, wow, it's still going. Oh, wow. A lot of messages here. It hasn't broken yet. Trying console, trying console, trying console, trying console, trying console. Wow. Somebody is really hitting the chat button hard. Okay. So, okay, it's still doing it here. But effectively, the same chat server is where I'm deploying this sample. And once the deployment is done, oh, there you go. Now it's done. So now I can refresh this page. And it looks like this. And if I refresh it here, it looks like this. OK? Oh, sorry. Oh, there you go. People are clicking, refreshing all over the place. So you can see, oh, whoa, whoa. Something is, OK, well, you get the point, though. OK, I should have maybe deployed it locally and showed it in a more demo environment. That's OK. I like it, keeping it clean. See, now, one thing is, I can go in an offline mode here. So let me click in the corner here. OK, so those changes are not shown over here. OK, and the part I want to show here is, if I hit transmit the snapshot, everything is cleaned up. A snapshot of the HTML5 canvas is taken and send it to all the clients that are listening. Think about this, multiple players can join from across the web, which is what you guys are joining here. And then you can click on so the reason you keep seeing it clearing up, because people who join in, they hit on the snapshot button, and it takes a snapshot of the browser and sends a clean snapshot to all other clients. Okay, that's why you see, oh, keep it getting clean. But in here, in the WebSocket, if I click on WebSocket, there are a lot of messages being exchanged. So all of those are shown over here. So what's really happening on the wire? Well, if I click anywhere, it's HTML5 canvas. So my JSON coordinates, my X and Y coordinates, my shape, and my color. Those three things are captured and sent as a JSON structure over the wire. So here it says shape, circle, color, whatever, coordinates, this, whatever. Okay, those are sent over the wire. And when I'm clicking on the snapshot, it's saying, oh, let me capture an array buffer and send it over the wire. So it's just showing you array, a text and binary transfer of data. So if I go back to my NetBeans IDE here, where is my mouse? I'm glad so nobody's controlling my NetBeans IDE. Here my server endpoint, I define the value or the URI where it's listening. I got my encoder and decoder. If I look at my decoder first, simple, here it says I'm going to decoder. It's a text decoder using the type figure. I take a string. I'm using my Java API for JSON processing to read the object, convert it into a JSON object. This is the only decoder, so I just return true if there are no parsing errors. Okay. Then in my encoder, again, I'm operating encoder.text on figure, and I take a figure, use the Java API for JSON processing, and return the string implementation of that. Simple on open, on close. I could have very well used my session.getOpen. I'm not really using the peers, but this is just to show your callback handlers. And here I'm taking on string, which is whenever I receive my POJO object or my string, which is decoded into figure. And here my payload is byte buffer. And if I look at my corresponding WebSocket script for that, that's again very trivial. So ws:/URI scheme, we change the port. This is what triggers my WebSocket connection handshake. The default type is blob. I'm changing that to array buffer. And I have my on message and on error callback handlers. So send text and send binary are being called from the browser page, but the underlying call is still WebSocket.send. So see, it's an overloaded method and works just out of the box here. Okay, everything else is more JavaScript magic that's happening behind the scene. So won't dig too much into it. Let's see how the thing is doing in the background. Oh, people are making all creative designs. Yeah, keep hacking it. All right. Once again, you can access this exact sample on this particular Git URI. In terms of the URI template matching, you can do the template matching very easily. This is following the REST design principles, or JAX-RS design principles rather. So you say /chat, room ID, whatever it is, at server endpoint, at on message, this is what we have seen. But this room ID can be easily mapped to a method parameter using at path param annotation, okay? Very simple. Let's take a look at how would you build a client endpoint now. So in terms of client endpoint, I take a POJO. On a POJO, I put add client endpoint annotation instead of add server endpoint annotation. Okay, I have my usual at on message annotation over here. String message sessions. The method signatures look pretty much same. The important part here is, remember we talked about server at the center and client at edge of the wheel. So client does not have a URI where it's listening from other clients. A server is the only one that has a URI. So in which case you have to have a client connected to a server and provided the class which is sort of the listener class. So in the way to do that is container provider, give me the WebSocket container. You specify the URI. This should really be the WS colon. So this hello would not work. Typo in the slide. I should be saying WS colon, the full URI in this case, and the class. So you're saying take this client class connected to this server on WS colon URI. All right, so let me show a simple sample. Now, this sample would work only on my machine because this requires a desktop installation. So for that, what I'll do is, here is my WildFly instance. So I'm going to fire up my WildFly instance. So what I've done is I'm very graphically challenged, so don't make fun of that. I like WebSocket, but I just made a simple Google Doc emulator. So I'm going to bring up two JavaFX consoles. This is written as a traditional desktop application, just to show you that WebSocket is not purely a web technology. You can use it in a traditional Java application, desktop application as well. Okay, so I got my WildFly server running here. Starts up pretty quick, in about 3 seconds. So here all I'm going to say is maven WildFly colon deploy. Okay, so it's going to take my Google Doc server, and it did not deploy. Apparently is already deployed. Just say redeploy then. Okay, so that deployed. Oh no, it didn't deploy because I haven't gone to the right directory. Okay, let's try this. All right, that's better. So my WildFly, my Google Docs server is deployed over here. Then I'm gonna go a level up, and I'm gonna just run my simple desktop client. Okay, so this is my Google Doc emulator using WebSocket. I'm gonna put this in the background. Okay, that's running. And I'm going to run another instance of this client. So there's one over here and another one over here. Okay, so I go here, and whatever I type here is being shown on the other window as well. So these are again my very traditional Java desktop application. You can use it for any desktop application. I just happen to be using JavaFX as a client. Let me show you the corresponding backing code for this one. By the way, this is all on GitHub, everything. We at Red Hat, we truly believe in sharing. I work out of the Mountain View office here, in the Bay Area, and we got a big, on the big wall size poster which says, our mom used to tell us, the more we share, the more we grow. So at Red Hat, we truly believe in that. So all of this is shared for you guys. I was showing the code behind this. Where does my mouse disappear? Oh, that is not added as a module, so I need to open it separately. So here is my Google Doc server. If I open up my server and open up my client, so the server is pretty straightforward. This is the URI where it's listening. Okay, all it's doing is just broadcasting a text. So nothing fancy in there. That's how typically most of my servers are going to be. Now, if you want to maintain a state, talk to a database, persist some values, that's where your logic would go. And if I look at my corresponding client, again, a simple one single class. This is a JavaFX application. The fact is extending application. Application is coming from JavaX application on line 8 right here. Okay. By default, I launch it. When I launch it, it does through the start method here. Here I'm connect to server. So if I look at connect to server, this is the code I explained earlier. I'm getting a WebSocket container. I'm saying connect to server. This is my client, and this is the URI where I'm connecting to. Very easy way to connect from client to server. Remember I talked about specifying the complete URI. So that's what you need to do. And then I have my usual on open, on message, how I want to refresh the two clients. Okay, so that's pretty straightforward too. All right. So let's talk a little bit about the programmatic endpoint then. Most of the times, and I would say typically 80, maybe 90% of the time, you might be happy with just starting with the annotated endpoint. Put the annotation, get going, and it's very easy to start with. And then you want to, if you want a little bit more knobs on dials, I want to look at the HTTP messages or HTTP headers that are being exchanged over the wire. Now, WebSocket is a stateful protocol. So every time a client connects to a server, a new instance of a server endpoint is created because that's where the state is being maintained. But if you want, hey, I want all the clients to share a single instance of the class, a singleton design pattern, that's where you get into programmatic endpoint. So these are knobs and dials which allows you to override the default behavior provided by JSR 356. It's definitely a little verbose, but that's sort of the design pattern that is follows. So here you're saying public class chat server extends endpoint. This is sort of this is not an annotation here. When you extend endpoint, you have to override this method. You have to add a message handler. Instead of saying @on message, you are adding a message handler here. And once again, you can add 3 message handlers, text, binary, and Pong. In this case, you're adding a text message handler, further overriding a message, and then you are communicating back to the server if you want to. So that's how the communication happens if you're doing a programmatic endpoint. Now, in terms of a programmatic endpoint, you need a little bit more details because remember we have not specified the URI so far. So in that case, you need 2 classes. One is the programmatic endpoint itself. The other one is called as a server application config, where you define what the endpoint configuration would look like. One of the methods that you need to overload or override is get endpoint configs, where you define a whole bunch of, so possibly you can have a bunch of endpoints, maybe all programmatic, and then you can have those programmatic endpoints defined in one server application config file. So for example, here you're returning a hash set of all the server endpoint configs. And in this, you're basically adding multiple entries right there itself. And in there, you're saying, for this class, this is a URI. Okay? So you can see already this is a lot more verbose than the annotated endpoint, but for a reason. I'm just going to walk you through this one. I'm not going to show this one. So here in this case, I have a WebSocket endpoint. I'm specifying, well, the configurator can be specified not just for programmatic endpoint, it can also be specified for annotated endpoint. So in this case, I'm specifying the configurator, and as you can see, I'm just concatenating the value that is being received from different clients in this case. And if I look at my configurator, I'm just overriding this method called as get endpoint instance. And in that, all I'm saying is just return a single instance of the client. So here, all the clients that are connected to the server, a single class or single server class instance would handle all of that communication. So it's truly, truly stateful, for all the clients in that sense. All right, I think we have time and we can talk a little bit about securing WebSockets, after which, I don't know, I don't see a need of a break. Anybody needs a break? Just a few hands, maybe. Okay, we'll see. Let's talk about securing WebSockets. Now, after securing WebSockets, I'll give you a break, don't worry. I'm just testing. In terms of securing WebSockets, so we looked at the HTTP headers that are going back and forth. So there's an origin header in the WebSocket handshake request. So it follows the origin-based security model. That means, so remember I talked about you go to WebSocket.org, you initiate a new WebSocket connection over there, that would work. But if you're on Google.com, so let's do that actually. So here. So I'm now, people are drawing all sorts of fun stuff here. So here I'm on Google.com, and I go to Developer Tools, and I go to Console, and here I say, I forgot the URL. Let me copy this URL here. See, I'm on Google.com and I'm trying to connect to WebSocket.org. It throws an error. Well, I think it throws an error because of HTTPS. But otherwise also, if you are on a different domain and I try to connect to WebSocket.org, it won't allow that because it follows the same origin policy. So that's there built into the protocol itself by default. In addition, we talked about how there are sec WebSocket keys. Or HTTP headers that are both at part of the request and the response. None of those, effectively, if you're running in a browser, as a browser application, you can use XHR to set those as header values. But if you try to attempt to those, and I wrote a simple application, it doesn't allow that. It does not allow you to set those values. Even if you set them, they're just being ignored. At least that's the behavior that I saw in Chrome. And I'm sure similar behavior, that's a requirement actually as part of the protocol. And because all the browsers, modern browsers are supporting WebSocket API, so I presume it's similar behavior in all other browsers too. None of those can be set. Without setting those values, a handshake request cannot be started, and you won't get back your sec WebSocket accept and all those values. Now, the other two mechanisms, if you're running in a Java EE environment, is how you can use a servlet security mechanism. In terms of servlet, the way it works is you specify the URL pattern that you're trying to access, and using that URL pattern, your resources are protected. Whatever is defined for servlet, the same rules apply for WS:URI scheme as well. So that's one way. Well, that's one way. The second way is, typically by the time you have reached or invoking your WebSocket endpoint, by the time you say new WebSocket, you can go with a username password-based authentication as well. That, by the time I'm going to get to the place where new WebSocket is called, I would have already prompted for a username login password, and then I initiate the WebSocket connection. So that's the second way of doing it, between user-based security and servlet security mechanism. Or in addition, which is typically what I've seen used a lot more common, is instead of using WS, you can say WSS protocol, which is basically running over HTTPS. So you have the full pipe secure, and then on top of that, you're running WSS. Now, the important part is if you are on a HTTPS, this is standard web principles. So if you are on HTTPS, you can't make a WS connection. You have to make a WSS connection. Okay? So let's take a look at it this little bit more detail. But before that, there is also support for codes in here. Basically, what is codes? Well, codes is a standard specification as of January of this year, I think. It relaxes same origin restrictions to network requests. So if I make a request from my browser to that WebSocket.org, which is hosted by Kazing, then in the response, they allow access control, allow origin HTTP header. And as part of that, basically says, you can call me from any other domain that you care about. Okay? There are lots of access control headers, and they allow your resources to be called across multiple domains, not from the same origin domain. the specification is defined on this URI. So let me show you the sample for the user-based security first. Endpoint security. Bless you. Okay. I'm just going to deploy this server on my WildFly instance here. All right. So here I go. And now I can get rid of developer tools. And I can say localhost 8080, and I say endpoint security. Okay. The moment I go here, oh, I don't remember what username and password I used here. The moment I go here, it says, oh, you're trying to access a page. So if I look at the code behind this, first of all, and that might give me a clue on what username password is expected. So here is my endpoint security. If I look at my webinf web.xml, in the web.xml, I'm saying every time you try to access /star, this is a security constraint defined on /star in the group G1. On this WildFly instance, I have already created, oh, now I remember, user1, which is U1, password is P1, group is G1. And here I'm saying just do basic authentication using file-based realm. So this is your standard Java EE security principles now applied to WebSocket. And how does it work? I'm not specifying any WebSocket here. So in this case, the moment I try to access index.jsp, in index.jsp, there you go. So it says username, password. So that's my clue. Here in my, I load my JavaScript here. And in my JavaScript, I try to create a WebSocket connection. And because the URL is already protected, so there are two ways. Remember, I'm protecting the page within which I'm calling a WebSocket, or I can say, don't worry about the page, just protect the WebSocket URI. Both the approaches would work. So now if I go here and I say user1 and password1, ta-da! Okay, so one way I protected, before I can invoke my WebSocket connection. Now remember, the WebSocket connection has not been established yet. So now when I say echo, there it says connected, sent, and received. Okay, so that's one way of dealing with it. The other way of dealing with this is, which is in a different module. These are my WildFly specific samples. Oh, no, never mind. It's in the same package. I was confused for a second. Where is that endpoint dash WSS? That's the, yeah, endpoint dash WSS. Or maybe it's not one of the open modules. So let me open that module separately. Java E7 samples. Go to WebSocket and open up endpoint. Yeah, there you go. So if I look at my endpoint here, again, that's very trivial, server endpoint / WebSocket. If I look at my web pages here, my index.jsp, again, simple echo endpoint, WebSocket.js, that's where the fun starts. So that's where I'm saying WSS instead of WS. So that's pretty much the only change in order to communicate over a WebSocket endpoint. Well, of course, it requires setting up key store, etc. But if I look at my web XML, that's where I'm specifying more of my configuration. And in this case, for example, all I'm saying is user data constraint, transport guarantee is confidential. So now when I make a communication or try to connect to this endpoint, it's going to use WSS over HTTPS. And there's a little bit of change, there is a little bit of configuration required in WildFly, and that's why I was thinking it's probably a WildFly specific module. But in WildFly, you need to specify, if I can show you my blog on that. Endpoint, oh, WebSocket endpoint, what is it? HTTPS miles to go. Not bad. Google is happy today. So in this blog, basically I explain how you can create a new simple key store. Then you start WildFly, you create a new security realm, and in the security realm, you need to restart WildFly after you create a security realm. But you need to specify what is the realm name, you add a key store, and all those. So the complete instructions to set up on the WildFly side are available on the blog, but the key part being, from your application, the only change that you had to make was from WSS, you made to WSS. From WS, you move to WSS URI scheme. Okay, I think it's 55 by my clock. We'll see you back in 5 past the hour, and that's when we'll start rest of the workshop. We got a lot of fun still planned. So there are some, Peter is going to show some fun stuff, with over here. We're going to talk a lot of pub/sub protocols over WebSocket. Now we're going to get a practical aspects of WebSocket, how to have an active MQ server and talk to them using WebSocket, how to do a cousin gateway and all the fun things. So see you back in about 10 minutes.
You're not that, you're not that, you're not that beautiful. You took the best of me, don't seem to need the rest of me. When will you realize that I'm still around? You've been ignoring me for quite a little, boring me, while you've been compromising all over town. Why would you think of making up? I guess you heard we're breaking up. Night after night I'm on my own, and now you're stalking me. Where did you get that attitude? I guess I'm just not in the mood. This is the end of the story for me. Come on now, why don't you get a clue? This love affair is through. All I can say to you is you're not that beautiful. Why would I want to stay? I can't go on this way. All that I got to say is you're not that beautiful. Been working day and night, been trying hard to get it right, while all my needs and dreams get put on the shelf. Love ain't no 9 to 5, ain't gonna be your pretty wife if I don't get a little love for myself. Why would you think of making up? I guess you heard we're breaking up. Night after night I'm on my own, now you're stalking me. Where did you get that attitude? I guess I'm just not in the mood. This is the end of the story for me. Come on now, why don't you get a clue? This love affair is through. All I can say to you is you're not that beautiful. Why would I want to stay? I can't go on this way. All that I got to say is you're not that beautiful.
All right. It's always a good thing to find out that people are still coming back from the break, and they're coming back to the same talk. So it's good to see some familiar faces. That means that we are not boring you too much. All right. There were a couple of questions, and Peter, you may want to come up on the stage here. So I was looking at the browser here. So one of the first questions over here that I'm looking at is, it says, how come you could open new connection from WebSocket.org to your Node.js server on cloud domain?
Right. So. Does it work? Okay, yeah. Excellent. So in order for CORS to be supported, it needs to be configured on the server. It needs to be set and supported by the server. In our overly simplistic server, there was no security headers sent back. So maybe as you go through the hands-on or the labs yourself, or maybe if Arun has that still up and running, we can take a look at it. The number of headers that are sent back are very limited, no security headers coming back. Later on, when we take a look at another WebSocket server, you will see that security headers do come back. For example, on WebSocket.org, actually, you can take a look at it. The security headers do come back, and that's why you cannot connect from a page that was downloaded from google.com back to WebSocket.org.
Yeah. I don't know, what does it say? That's not a language that I understand, but it talks about IDE war. So I guess it's something to do with NetBeans, Eclipse sort of stuff. One of the questions here is, what are limitations for a message length? We'll cover about that a little bit later in the presentation. There are message lengths. Typically, when you send a message, it's basically mapped to a WebSocket frame, and we'll talk a little bit more about that. There are 3 more messages here. How did you restore the session after going online back again? Restore session.
So this can be a somewhat tricky one. As you imagine, a WebSocket connection is a stateful connection. So unlike HTTP, where you make a request, response comes back, and the connections go away, they are broken down, a WebSocket connection is a permanent one. So when your connection goes away, then you have a problem. And in the world of mobile devices and flaky Wi-Fi connections and whatnot, your connection may go away. So this is a functionality that can be done at a somewhat higher level. We are going to talk about how you can use WebSocket as a very low-level transport protocol and how you can layer higher-level, richer protocols on top of that. And this can be handled at that level. So whenever the connection goes away, then you can have some client magic, typically a client library, that detects that and can attempt to reestablish the connection. So it really depends what implementation you're using. The standard itself does not define what you need to do. There are best practices, what you can do. When Arun described the event handlers, one of the event handlers is on-close. So on the client side, you can detect that your connection went away, and typically that's where you would put your reconnect logic.
Right. Now, is it possible to disconnect any client peer intentionally from the server endpoint? Now, remember when we were building chat server or WebSocket server, on the Java side at least, on the Java EE API, you're maintaining the list of all the clients. And for each client, you do have a unique session ID. So yes, you can explicitly from the server side say, you know what, just close that connection, and then the client can be pushed away. We definitely need a singleton annotation added to the WebSocket JEE API. Oh, it's not JEE, it's Java EE, guys, first of all. Second, and yes, we do want a singleton annotation API. The best way to contribute that, this is a fantastic tweet, but it remains a tweet. So the best way to contribute is go to the JSR 356 website, which is on java.net, file a Jira issue over there. Because that's, if it's an issue, it's an issue. If it's not filed as a Jira, it's not an issue. That's how people see it. How do you synchronize request with response when you have to? So as we were showing earlier, in the Java land at least, by just using normal Java programming model, you can, you send a request and you get a response back. It's a stateful protocol. So on the server side, you're supposed to maintain all of that state information. You have anything to add, Peter?
Yes, I am going to show, when we come to the pub/sub topic, I'm going to show you some patterns that work probably even better than traditional request response. Actually, what we have seen is that the biggest challenge with around the topic of having a socket connection over the web is changing our mindset, getting the whole request response kind of paradigm out of our mindset. And I'm going to show a couple of examples that demonstrate this really well, where instead of the client making an explicit request for possibly something available on the server, the much more natural kind of pattern or paradigm is the event-driven way of doing things. Whenever you have anything to share, you share it. Whenever the server has something to share, he can share it with the client. And this whole request, I mean, there are valid patterns for request response, obviously, but now you are not tied. You are not forced to just use request response.
Now, Peter may be shy. Here is a book that he wrote, which is Definitive Guide to HTML5 WebSocket. It's a sort of a short pocket guide, but I think it's an excellent resource for learning everything about WebSocket. Very technology-focused, product-agnostic book in that sense. So if you want to understand the fundamentals of WebSocket, I think this is a great book.
Aaron told me that he was going to plug my book if I plug his. So he brought a handful of books, copies of the... There you go. Java EE and HTML5 Enterprise Application Development, and I think he has some plans with it. He has 5 copies of...
Well, these are for takeaway, so by all means, you can run and have a war,
run on 1, 2, 3.
Grab the books. This is not for takeaway. This is Peter's personal copy. So yeah, let me see if there are any more questions here. How well does a server scale when it has to maintain one socket per client? We will talk about that. What are the biggest limitations of WebSocket, also known as C10K problem? What is C10K? Canonicalization? I don't know. We don't know about that.
We'll need more detail about that.
We need more detail on that. Is it possible to connect 2 web client browser with WebSocket? Yes. I mean, I can have multiple tabs open and they can all connect to the same server. That's entirely possible.
I think this question is about the peer-to-peer nature of the connection. Just like with HTTP, you have to have a server component in the picture. So you cannot have a native peer-to-peer connection between 2 clients or between 2 browsers. Communication always has to go through the server. There is a sibling standard, WebRTC, that does allow peer-to-peer communication, has peer-to-peer capabilities. There are many, many challenges with WebRTC that you can face in a real-life environment, and very often those challenges are solved in a very WebSocket-y way, where the peers are connecting through some server and the signaling is going through some server. But WebSocket does not support peer-to-peer communication. You have to have a client and you have to have a server. It's asynchronous when it comes, or asymmetric, I should say, asymmetric when it comes to creating the connection. So it's always the client that expresses desire to create a connection, tells the server that, hey, I want to create a WebSocket connection, and then the server responds back that, okay, let's do WebSocket, and the HTTP connection goes away, and a WebSocket connection replaces that. And then through the server, the clients can be connected, but it's always through the server.
Okay, one of the questions is, how would this work in a multi-server environment with load balancer? We'll talk about that. That's already scheduled in the presentation. What's the minimum version of JBoss that supports WebSockets? So JBoss EAP 6.3, which is a commercial version, already provides a technology preview of WebSocket. 6.4, which is supposed to go live any day now, will have a supported version of Java API for WebSocket. And of course, if you want to try WildFly, which was released in January or actually February of this year, already has full implementation of Java EE 7 WebSocket. And I showed you a sample that was running the collaborative whiteboard, the chat server, they were all running on the WildFly instance running on OpenShift. And can I have such a book? Yes, you may. This book definitely you can buy. It's from Press. You can buy it. I have 5 copies of these books. By all means, can ask me nicely, give a nice tweet, and then you can have the book. All right, I think we're going to switch back to our presentation. All right, we have about 75 minutes, a lot more fun things to plan, a lot more fun demos to show. So I'm going to talk a little bit about embedded WebSocket. So what is an embedded WebSocket? We have talked about we know about embedded web servers. How do I run embedded HTTP servers? So embedded WebSocket, basically, I'm referring to how you can have an embedded server and within which you can have an embedded WebSocket. So within a VM, you can easily spin up a WebSocket server endpoint. So for that, the approach is to use Undertow. Undertow is a brand new web server that is part of WildFly, which is, if you know WildFly, WildFly is the Red Hat's open source application server, what used to be JBoss application server. As part of WildFly, we wrote a brand new web server, used to be Tomcat, legacy code, but this brand new web server works very well. And there were reasons to write a brand new web server so that it gives us that scalability, that performance that we need from it, and I'll show you numbers on that. But basically, it provides you both blocking and non-blocking based using NIO APIs. You can write different handlers, and then you can compose them the way you want to do that. So for example, you can write a WebSocket handler, and then compose it, say, hey, Undertow, allow to handle my WebSocket connections over here. It's a very lightweight, very lightweight process in that sense, and fully embeddable. That's what really gives you embeddable WebSocket. Remember, we said when we start a WebSocket connection, it requires an HTTP upgrade. In the Java land, HTTP is supported by the servlet specification. So Servlet 3.1 added support for HTTP upgrade, and Undertow, in that sense, supports Servlet 3.1 and HTTP upgrade. And the cool part is Undertow also provides support for Mart cluster, which is how you do your load balancing in that sense. Okay, so Undertow, it came as not as a surprise, but as a pleasant surprise to us because we have done some performance benchmarking with Undertow. Tech Empower, you can see the blog URL in the bottom here. Tech Empower is a third-party website which does performance benchmark comparison of 90 frameworks. They use the term framework very loosely. Spring is a framework, Jetty is a framework, Grizzly is a framework, Undertow is a framework. So everything is a framework to them. But nevertheless, they did comparison of 90 frameworks, and Undertow was pretty much among top 3 in all different ranges. And here are the benchmarks that came out. They were able to do 1 million concurrent requests per second on a beefy machine, but 1 million concurrent requests per second. And this is without any customization. There is no customization, no tuning, nothing that's done. So it's effectively 31 million concurrent connections, 31 over 30 seconds. So more than 1 million per second. So that kind of gives you the ballpark of how powerful Undertow is. So with that, I am going to show you a simple example of Undertow, which you can, by the way, try yourself. And these slides will all be available. So you can check out this Undertow Git repository, which is what I'm using for showing the samples. I've pre-built the samples, and I'm just going to run a simple JSR WebSocket sample, and it did not like it. Please point your browser to this. Let's see, I don't know if it's going to work or not, but let's try it. Oh, address already in use, of course. Yeah, here you go. That's an easy one to debug. Right in the middle of a demo. So let's fire it up again. Okay. So let me run this JSR WebSocket sample. There are a lot of samples here. I'm just going to run a simple sample here. So if I go here, here's a simple chat sample. So hello and hello. That's it. Looks more like an echo sample, but it shows the point. So now if I go back to my slides and I copy this URL here and I go here, and I show you the samples here, and here is my source. And I look at the JSR WebSocket sample here. So here is my JSR WebSocket server. Well, before that, I want to show you the JSR WebSocket endpoint. Now, endpoint again is very trivial, as I said earlier. We have seen this multiple times. Server endpoint annotation on message, just iterate and send the response back to the client. In the WebSocket server itself is where all the magic is happening. It's a little bit more elaborate code. You say Undertow builder, add a listener, set a path handler, you're just using a default path handler here. Of course, a little bit verbose code because you're embedding everything. You're composing how your WebSocket endpoint is going to look. Then you build a deployment info. Don't worry about too much details here, but the key part is you are setting the context path here, adding a welcome page. Here is your deployment info, and you're specifying the endpoint class name. And you just specify it a war file name, which is generated for you. And that's it. So that's how typically you would do your embedded WebSocket if you were to do. And remember, this is all done just using Maven run the file itself. So just that simple jar file will do everything for you. All right, somebody asked a question about load balancing WebSocket. Now, WebSocket is a stateful protocol. Okay, so first part to understand is when you make a TCP connection, that connection is held onto. The state is maintained between both client and server. So the most common question people ask me about WebSocket is, oh, how do I do my session failover? There is no such concept of session failover for WebSocket. That concept is valid for a HTTP request because you have, there is no state, but you want it to fail over on a different server. So in case of WebSocket, if you're making a connection to the WebSocket server, if the connection is gone, the state is lost. There is no failover. With WebSocket, with HTTP, people talk about horizontal scaling. With WebSocket, it's all about vertical scaling. You add more beef, add more memory, things like that. So that's the way you do it. Well, that's one way of doing scaling. The other part is where you can have multiple servers, and you can start segregating. Oh, if a WebSocket connection is coming from this particular domain or a geo, I'm going to guide it to this particular server. So you can use your standard Apache HTTP proxy modules to do that load balancing. So reverse proxy is one mechanism, which I will show today. Apache has a module called as mod proxy _ws tunnel. So you can use that to fire up your WebSocket proxying from Apache. We talked about only vertical scaling, and we talked about no session replication. Okay. So let's take a look at this blog. The blogs really make my life simple in conferences. Again, the complete detailed instructions, I call them as tech tips. These are complete detailed instructions which you can follow and replicate the environment that is running on my machine. Simple sample again, provided over here. Okay, so you download WildFly here. So if I look at this particular file in httpd-conf, okay? Let me stop this guy here. Okay. So in here, I have all these modules, okay? So the one that I'm looking for is mod _proxy _ws tunnel, okay? It's kind of hard to read, but if you see this here, this particular module is the one that is uncommented for you. By default, I compile this Apache HTTP server on my machine, on my Mac, because I needed a specific version that was not available for default. So I downloaded the source code, went through the pain of compiling all of that, and then it gave me the default configuration file. Then I uncommented the mod proxy WS tunnel module. Okay, so and few other modules as well. So once you uncomment the module, then you need to look at your end of the HTTPD conf. Okay, so here once again, just like your standard HTTP proxy here, you're defining a load balancing cluster. Okay. In the cluster, you have two balancer members. So for example, localhost 8080 and 8230. If you fire up HTTP or fire up WildFly in a domain mode, then, well, WildFly first of all can be run in a standalone mode, which is a single instance of WildFly, or in a domain mode, which is sort of a centrally managed, administered mode of WildFly, where you can run multiple instances in the background very easily. So if you start up WildFly in a managed mode, it starts up a domain administration server, and in the background, it starts up two instances of WildFly. Those are on port 8080 and 8230, okay? And all you're saying is just proxy my /chat URL to this cluster with /chat, and these are my two balancer members. So here you go. Let's try this now. So if I see localhost, My Apache is not running, so let me fire up my Apache then. Okay. So this is my code to compile. This is installation. Okay, this is the code. This is how I start my Apache server. Okay, so let's get out of this, fire up my Apache server. Okay. All right, so this starts my Apache server. I go back here, refresh the page. So Apache is up. Okay, then all I'm going to do here is I am going to start, well, if I go to bin directory here, so see there is a standalone which starts a single instance of WildFly, or there is a domain.show which starts my managed instance of WildFly. So I'm going to start up on the domain mode. Okay. Now once I start up in domain mode, I can access say 8080. That's one. Oh. No, I think it's not refreshing properly. There you go. Okay, so that's WildFly 8080. And then I can run it, I can see 8230 as well. So both my ports are up and running. Now my chat application, which I changed the port earlier. So if I go back to my chat application, so I can just say revert the change here. Okay, so it goes back to the default port. Now I go back to my okay, so got to skip the tests here. Sometimes too much testing is like, I don't want that right now. So let me deploy this to WildFly now. The same chat sample. And it tries to run the test again. Don't run the test, please. Please don't do that in production. Oh, you know what? Hold on. Actually, this is running in a domain mode, so I need to deploy it manually here. I have my Maven profile is not configured. All right. I need to add a user to my WildFly 8.1. The idea is when I'm trying to bring up the admin console of WildFly, it says, hey, you're trying to do something in the administration realm, and you don't have an administration user, so we need to add a simple user over there. So all I'm going to do is add a user, and I'm going to use in the management realm, and I'm going to call the user as admin. Admin is easy to guess. Yes, please, use it. Password, just keep it dumb. Oh, yeah, this is restricted. Yeah, go for it, no worries. Re-enter the password. Okay, no groups. About to add user to management realm. Yes, not connecting remotely. Okay, that is created. So now when I go back here, it says admin and I enter the password. I'm in now. Okay, now if I go to say runtime and I say manage deployment, okay, I can add a deployment here, choose a file here, and workspace, Java E7 samples, WebSocket. So this is a weird bug with Yosemite, you know, I mean, if no date, what do you mean no date? I just built it. It should show up at the top. So I pick up a chat here, I deploy it, take the name as is, save it, okay? So it's a two-step process. First you upload the archive, then you assign it to a server group. Then I'm going to say assign it to my main server group. Okay, and I'm going to enable my war file. So once that is done, so now here on my 8080, I can say chat And then here on 8230, I can say chat. And the good thing is, now on my local host, if I say chat, it's available as well. So see how my Apache load balancer was able to take two WildFly instances at the back end and front end it very easily. One of the things that is missing here is it's not showing me. I thought I got that application. Oh, you know what? That's a separate, different application. In a different version of the application, I was showing the node instance which was serving this particular chats application. So by default, it comes from 8080. So now if I go back into my console here, I can say overview. I'm going to just say stop one server, which is running on port 8080. By default, the port offset is 0. That means 8080 plus 0 is 8080. So I'm going to stop this server. Okay. So operation successful. Now I go back here, I refresh it, and it still comes up the same, because now it's being served by a different instance. So again, you have in the blog, you have all the details, what modules to configure, how to configure your balancer, how to configure your balancer members, WildFly, all of that is available to you. All right. So with that, we're going to talk a little bit about PubSub. And Peter can actually talk about PubSub over WebSocket, and we'll show a bunch of samples over there.
Sure. Do we want to, maybe we can take a look at the slides first. So Arun has described a couple of very valid and very interesting use cases. How you want to take advantage of WebSocket, for example, when you are running a node in the backend. Then we talked about how we can plug this whole new communication pattern when you are building a Java EE, right term, Arun? Java EE application.
Yes.
So I'm going to show a slightly different spin of the whole story that I think is extremely powerful and is very popular, especially when you have enterprise messaging in the back end of your enterprise, or you're simply building a highly distributed environment and you want to connect them. The whole idea of WebSocket was to bring the power of TCP to the web. There were attempts before to do something similar. Flash had a notion of socket. Java Applet had a notion of socket. They failed mainly because they were not web-friendly socket connections. And WebSocket was designed not only to be web-friendly, but also to be a very low-level transport layer protocol. As I mentioned, a TCP kind of layer for the web. So putting higher-level protocols on top of that is something very natural. So one of the simplest PubSub protocol is the STOMP protocol, Simple Text-Oriented Message Protocol, which, despite it having the word simple in its name, is simple. Most of these terms that have simple in them tend to be pretty complex. So it is a wire protocol format, and this is something that we have experimented with quite a bit. It provides interoperability regardless of what programming language you're using, just like WebSocket does. JMS, if you are familiar with JMS, it's an API. It does not specify what data is going over the network. So if you take a JMS message broker, you would need to know how to talk to that message broker at the protocol level. For you as a developer, this is hidden typically by the API, but you need to know the underlying protocol. Okay, so what I would like to do now is I'm looking for the.
Do you want to show the WebSocket stomp?
The MQTT sample.
Do you want to show the WebSocket stomp sample first?
Sure, we can do that.
Yeah.
Let's switch over.
So I can show the stamp sample here.
Okay.
Okay. So, well, for the stomp sample, as Peter was talking about, we need a still broker, a broker, a PubSub broker that would actually be able to understand the stomp messages. I mean, I love to call stomp as a REST for messaging. Because if you see here, for example, the verbs are connect, send, subscribe. Those are simple verbs that map very well in the pub/sub world. So what we're going to show here is how easy it is to provision an active MQ server. Once again, we are using OpenShift. I like to keep my development machine clean, have everything running on OpenShift. Once we have the active MQ server running up there, then from my machine, I'll be able to run a simple stomp client and be able to communicate messages back and forth over there.
So while you're working on that, maybe I quickly describe the architecture.
Yeah.
So what we have is a message broker sitting in the back. The purpose of the message broker is to route messages between publishers and subscribers. Publishers are typically defining where they want to send the message. This is abstracted by something like a topic or a queue, just like in JMS. And then the subscribers can express interest in the contents that are coming on a specific topic or a queue. So they subscribe to that and they auto-magically receive this. Now, this is something that has been around the whole pub/sub concept for 15, 20 years within enterprises. But more often than not, this has been constrained to the enterprise network. You would have to get on VPN to from the outside if you wanted to do something like this. And now these demos show how you can do the same thing over the web without any of that network constraint.
Right. With OpenShift, we can we can install any component over there. It provides a whole bunch of applications that can be easily run over there. But if you want to run something custom, it gives you the mechanism, what we call as a DIY cartridge or do-it-yourself cartridge. So I wrote a simple cartridge, and as part of that, all I do is I download ActiveMQ 5110, I configure it, change the ports and IP addresses that are required to match the OpenShift requirements. But now, basically, I'm just spinning up an ActiveMQ instance on OpenShift Live. So literally, that's what it's doing right now. So once the ActiveMQ instance is running, I'm going to use a simple client, which is what I'm going to use to send pub/sub messages to that ActiveMQ instance running. Okay. So now what I'm going to do is I'm going to go to my WildFly samples, and I'm going to use my WebSocket stomp sample over there, and I'm going to run my WildFly instance in a standalone mode again. That's a lot more efficient for me. And then in here, I'm going to go to my WildFly samples, WebSocket stomp. Okay. So once I go here, then all I'm going to say is WildFly : deploy. This is going to deploy my WebSocket stomp sample to the running WildFly instance. Now this is a simple web application so far. Where is my application is already created, which is good. And I've deployed my WebSocket stamp web application. So all I'm going to do is I'm going to port forward with ActiveMQ application, which is the application running on OpenShift now. By port forwarding, all I'm saying is go figure out what ports are exposed in ActiveMQ and forward my local ports to that particular application. So it automatically does the port forwarding over here. And I believe this is MQTT protocol.
That is MQTT.
That is
yes.
MQTT. Okay. So and I think that port is stomp protocol port is already baked into the application. So we'll take a look at that. WebSocket stomp. Here you go. So if I open up my developer tools here, okay. All right. So here is my developer tools. As you can see, again, a graphically challenged UI, but that's not what you come to hear me. If you want to hear about graphically interesting applications, then you go to other talks in that case. But if I go to my network, okay, so now I'm going to say payload is foobar, and I'm going to say q1, okay? That's my queue over here. So first thing I'm going to do is connect. Then I'm going to send a message, then I'm going to subscribe, and then I'm going to disconnect. Just do those things simply. As soon as I connect it, I see WebSocket connected. It says the payload is foobar to this queue, and then I say, got a message with body foo bar, and when you disconnect, it says, hasta la vista, baby. In the terms of, if I look at my developer tools here, you can see connect was the first message. I say login, admin, passcode, admin. I can start passing parameters when I'm connecting to a Stomp broker. And remember, when I say ws:/localhost 61614, it's localhost, but the request is directed to the active MQ instance running on OpenShift. That's what is happening behind the scenes. So that's my connect. Here is connected, a simple heartbeat. Then again, it's a send verb. Send is a Stomp verb. Then I have a subscribe here, then a message, and then I disconnect. So simple, how Stomp frames are directly mapped to a WebSocket frame. Very clean mapping that way. Jeff Mesnell, he wrote this WebSocket over Stomp JavaScript library that can be integrated and called from a whole variety of languages. So though Jeff is not here, here is something I want to pitch for him. It's a wonderful book that he has written. Jeff Mesnell is a wonderful colleague. He works at Red Hat with me. He works in the messaging team at Red Hat. He has written this book, Mobile and Web Messaging, which provides you great details with Stomp and MQTT and other protocols that work on top of WebSocket very neatly.
So what is very special about using these protocols and these libraries is that the vocabulary that you use on your client side in your application changes right away. And instead of just doing the simple message handlers and send messages that WebSocket provides, now you have the notion of these topics and queues that give you the level of abstraction that will make you a lot more productive.
And which is very important because, as we said, if you realize the first half was all about low-level protocols so that you understand what WebSocket callback handlers are, how the messages are being exchanged on the wire. But how many times would you really write those applications? You really need a higher-level library to do pub/sub and protocols like that in order to be more productive. You don't want to deal with on-message and on-callback handlers. From the Java side, it's okay probably, but from the WebSocket API, JavaScript API, it's going to be too much work if you have to deal with that kind of things. For example, one of the things that is missing in the WebSocket protocol itself is the ability to reconnect back to the server. How do I do that? I need a higher level library to do that for me. Well, we are leaking into our talk, but we'll give a quick, this logo is incorrect. I'm going to give a quick introduction to MQTT and then you can show the stuff. Well, just like Stomp is a simple text-oriented message protocol. MQTT is another messaging protocol. It's a very lightweight pub/sub messaging over TCP. That's how it was originally designed. And when I say lightweight, I truly mean lightweight. People tend to use lightweight for any kind of sumo wrestlers also. But this is truly lightweight because when it was designed, it was really designed for small footprint with a very constrained resources or a limited bandwidth. For devices that are possibly deployed, in a jungle or in a very resource-constrained environment, very limited memory or processing power. MQTT 3.1.1 literally became an OSI standard, I think, a couple of weeks ago only. So that's pretty cool. And it's a binary protocol. Just like Stomp is text-oriented, MQTT is binary-oriented. But there are two interesting concepts that are available in MQTT. First is you can define quality of service. Quality of service could be in three different layers. Three different levels. First is at the TCP. Then you can set the number as 1, which is at least once. And then you can set the number as 2. That means at least deliver the missed messages so that if the subscriber goes away, you are still able to receive the messages when the subscriber comes back later. And then the second one is last will and testament. This is a very important concept of MQTT because specifically the way all these MQTT agents are deployed in these remote environments, last will and testament says if the agent goes away, after the agent is gone, send at least one message, which could be like, hey, by the way, I'm gone. So, and that can be sent, that is sent even after the agent has gone offline. So that's pretty cool. Showtime.
Okay, let's switch these around.
Yeah. Ta-da.
So to hammer the point away, how important it is to support these higher level protocols. If you think of building like a proper traditional thick client chat application, you would never think of going against TCP directly. You would use JEB or XMPP for it. If you're building an email application, you would use IMAP or SMTP or POP3. The same kind of concepts apply here. So thank you. Let's switch to my machine.
Yeah.
And describe a little bit what I have here. I'm going to show you MQTT in the browser. I have an ActiveMQ server running here. This is the Apache ActiveMQ, same thing that Arun has been running around with. It is configured, has a special demo config file that I use to start it up to have MQTT pre-configured. And here I have a client. HiveMQ is an MQTT message broker, but along the same lines of the trick that Arun used before, I'm going to use this web client to connect to the message broker that's running on my machine. And I'm going to bring up another client here that is the out-of-the-box ActiveMQ message client. Actually, that's not how I want it. Okay, open them in 2 windows. So what I'll have to do is I'm going to connect to my host. This is the port, and let's make the destination /devox. And here I connected. And then in the other client, we are going to connect as well. This is going to be localhost, and the port is 61614, and connect. So now both of them are connected. This guy here automatically subscribed to the destination /devox and is going to publish there as well. So this is kind of a simplistic UI. This one here has a little nuance to it. We can subscribe to a destination. So let's subscribe to /devox, and we can also publish to /devox. Okay, so we send hello world, and as you can see, we have received, and the guy over here has received hello world. And now I say hi there, and it goes back hi there. Okay, if we switch to the developer tools, we would not see anything really in here other than the...
You have to refresh the page in order to see the network traffic.
So let's connect again, localhost 61.61.4. Connect. Here we go, and here we see the handshake, the WebSocket handshake. And when we go to frames, all these frames are binary, as Arun mentioned. Okay, so if you wanted to look at the actual messages, MQTT messages coming back and forth, then you would need to use other tools like Wireshark. Okay. Let me show you a couple of other examples. And here I am going to use an architecture where I have a back-end message broker that is front-ended by a WebSocket server. This WebSocket server happens to be Kazing, but could be anything really. And the idea is that the clients are connecting through the WebSocket server to this back-end. So let's see, given that we are in a Java context, I'm going to show a JMS demo, and I think I have a hard-coded IP address here running on port 80. Okay. So in this window, what you can see is that we are going to connect to a destination. This is going to be our endpoint, our WebSocket endpoint. And just like before, you can specify a topic or a queue. If you say /queue/queue name, then it's a queue. If it's you say /topic, then it's a topic. So it uses the JMS kind of lingo for it. And now I'm going to open another client. And you see very much the same story that we saw with MQTT, where here we have the contents, we send it, and you see it was sent, that's green, and it was received back, it's in blue, and here on this side, we only received it. So it's very straightforward and very easy. And on the application side, all you need to have is a notion of a topic that you can send and subscribe to. Okay, now I wanted to show you a couple of other examples that you can build with this paradigm. And that would be, I call it a light table demo. And to make it happen, I need to get my iPad up on the screen. And the way we'll do that is that I have an AirPlay server running here on my machine. So let's give this a try.
Can do something?
In a moment. Okay. So hopefully, here we have my iPad on the screen. And I'm going to open the same URL, which is this one. Okay, so what you see here is, maybe we can resize this guy a little bit. They're side by side, is that they access the same page. And it shows a kind of a similar functionality to what the Google Doc example showed, where you have two instances of the same app, and you can see the interaction in one or the other. So I'm going to move this image with my mouse on my laptop, and you can see that it's moving on the iPad. And now I'll take my finger and put it on my iPad, and I will start moving an image here on the right-hand side. You see that my mouse cursor is not moving on the desktop, and it's moving the image over on the other side. And the best part of the demo, and this I think is one of the possibly best visualizations of the bidirectional nature of the WebSocket standard, is that with one of my hands, I'm going to move this image here, and with my other hand, I'm going to move the other image over on the iPad. And the two images are moving at the same time. So we can do image manipulation. You're working in one corner, I'm working in the other, and we see each other's interactions live. Do you want me to smile? Okay. So this is part of the magic. And again, this specific demo was built on top of JMS. What's happening is that the mouse actions are transmitted, are published to a well-defined topic, and then they are consumed back.
So I think that's a very important part to understand, that, as you were saying earlier, the first half focused primarily on the lower level API protocol, so that you understand the nuts and bolts, but then you need eventually libraries like these to build real applications. I mean, you can't really leverage those on open, on message, on error to do all of that protocol handling by yourself.
And there are many, many libraries out there that are very useful. If you are a Node user, you would probably be using something like Socket.io. If you are a Java person, then actually, speaking of Java, I'm going to show a couple of additional interesting things there. Okay. So what you see here on the screen is a WebGL rendered race car running in the browser. I think it's pretty impressive just by itself how nice the reflections are, and it has a mirror, so whenever the camera is in the right position, you would see the reflections there. And you can control it using the keyboard, and you can drive it around, but that's not what we are here for. I took my phone and I opened up a web browser in the phone, and what I will do is I will enter the pin code that's on the bottom of my page. And by doing so, I connected to the same WebSocket server that the car is connected to, and by tilting the phone left and right, I'm controlling the wheels. And then I can tilt the phone forward, and it's driving the car around. So what's happening here is that I'm using the accelerometer here and the phone. There are events firing as I am tilting the phone. These events are published to the gateway, to the message broker, and then they are routed back to the desktop because the desktop said that it wants to subscribe, and that's how I am driving the car around. So again, this is all in the browser. The next thing I wanted to show is.
So the messaging protocol for this on the background is MQTT?
This one was JMS as well.
JMS, okay.
Yes, this one was JMS over a binary protocol. Previously, we were doing JMS over Stomp. This one was JMS over a binary protocol. The next example I wanted to show is is an example that is used by for dashboards, monitoring, or even trading. What you see here is, and maybe I can zoom in a little bit, is you see simulated quotes coming to a foreign exchange-like application that runs on your mobile device exactly the same way as it runs on the browser. And here you see probably you can check out, it's 150, 180, 190 messages per second that are coming in and processed into the browser. One very important thing here, and that kind of ties back to the grandma mailman story, is that the browser is not doing anything. The browser is idle. It's waiting for the mailman to ring the bell. And as the messages are coming in a true event-driven manner, it can re-render the relevant part of the UI as the message comes in. So you would not see any polls or requests going out. And this is what I meant about the request response nature or aspect. Okay, there is one more thing I wanted to show, and that would be on the iPad. Just to see the range of the kinds of things that you can do around here. So this one is a simulated cash register. Let's say that we are in a store and we have our basket full. And I am the cashier and I'm going to log into my cash register. And as I do that, I see all the items that I can go ahead and scan, and I'll go ahead and scan the first two items that you have in your basket. And then I come in with my phone, and let me put my phone on the screen as well. Okay. So let's make them bigger.
I can hold something.
Yeah, that would be great. Thank you.
Yeah.
So here is my phone, and I'm going to bring up a QR code reader because I am the shopper and I am connecting to this cash register. So I scan the QR code, and I want to follow along as the cashier scans the items. Okay, so as I connect, here we go. The two items show up in my basket, and I can scan more items. And as I am scanning more items, they show up in a synchronized fashion on the phone as well as on the mobile device. And now the time has come for me to pay, so I press the blue button on the iPad, and I go ahead and pay. I log in to my wallet as the shopper. It's 1, 2, 3, 4. Don't tell anyone. And here I see my cards. I can scan through my cards. And now here is kind of a little bit of magic. I'm going to put the phone here. So you see I need to hand over somehow my card. So the visual kind of representation for that could be that I swipe over the card. And as I swipe over the card, it swims over to the iPad. Eventually it comes back to me. The card is scanned. And here I have my cash register, or my coupon code, so that I come back later on. Now, this has a little bit of an extension, and I wanted to show that because I think that's more important than the actual visuals here, although those are not bad either. And that's going to be what we see about this in the back end. So there is a way to monitor what's happening in the back of your application. And again, this is part of the power of PubSub. So I'm going to start the whole experiment from scratch. We reload the page on the iPad, and notice that there is a message that already arrived to the merchant's dashboard that says the cash register came online. So we can expand this, and when we expand it, we see the geolocation about the cash register, and we see some more details. Let's go ahead and oops, let's try to get this guy up. Let's try to, yeah, we already signed in here, so we should see. I'm a little challenged with the Windows. We're a good team, aren't we? Okay.
You know, I think your problem is you're using Windows.
Okay, so a second message came in that the user already signed in. I'm going to scan the QR code again. And as I scan the QR code, the two devices are going to connect. So here I am. I'll bring it up. And you see the client, the phone already sent the messages that Okay, it came online. Let's add a couple of things to our basket. Charge, I'm going to pay. I log in, 1, 2, 3, 4. And here, let's switch over to the dashboard of the, let's say, the card issuer's view. So as we are going to go ahead and finish the payment. Oops. I don't know what my password is here. Okay. We swipe it over, it goes over. Notice that the message showed up on the dashboard, customer card charged, payment settled. So it shows you how these loosely coupled systems are all connected. It's not only the two clients, but it's basically the entire back end is very nicely and very easily integrated. Again, this is nothing new as far as the messaging part is concerned, but it's new that it's all happening over the web in a very transparent and in a very seamless fashion. Okay, was there anything else you wanted to add to this?
No, I think that's awesome.
Okay.
You know, I mean, how many times you have so many devices involved and the demo work flawlessly? That's awesome.
Okay, the next one I would like to show is this truck here. You may have been wondering what the truck was all about. So let me tell you a few words about this one. So one rainy day, we went to the local toy store in California, which is Toys R Us. And we bought this truck. And it was a radio control truck. We ripped out all the radio control functionality, and we mounted a Raspberry Pi on it. And our idea was to use the Raspberry Pi, which is this credit card-sized computer, to control the various servos of the truck. But we wanted to do that in a way where the controlling is happening over the web. So what we did was, and I need my phone for this, is we plugged in a little USB Wi-Fi card into the Raspberry Pi, and we mounted, or we put JMS, a Java application onto the Pi. And this actually emphasizes or gets the idea very nicely across that in this world, the language of your client doesn't really matter. We've seen JavaScript clients primarily in web browsers, but as Arun mentioned, you can build Java clients, like the JavaFX example, and this one is more on the embedded side. Although this is not proper embedded, this is a proper JDK running on the Raspberry Pi, it's powerful enough, but it can be a first-class WebSocket client. And as long as it's a first-class WebSocket client, we can do the same magic as we can do with any web application. So we basically wanted to take the racer from the screen off and drive around ourselves. So I'm going to open my browser, and I will go to a URL. Oops. Let me see here real quick. Yes, this is it. Okay, so you see this is an extremely simple UI. We designed this UI with Arun together. And it has a couple of arrows and a couple of buttons there. So the first thing I'm going to do, and we'll see if the camera can see this, I'm going to attempt to turn on the light of the truck. So not that easy. Let's try again. So I'll turn on the light, and it did not come on. Oh, it did come on. Oh, actually, this one fell off. This one, this light is on. So you can see the light is coming on and off. I can steer the truck left and right, and then I can spin the wheels as well. So let's put it down and do the same thing.
It's a monster truck, man. Let it rampage.
Oops, there we go.
Out of range.
So, thank you. So again, the idea is that the Raspberry Pi running a Java client is connecting to the same WebSocket server as the phone that has a web browser, and it shows the interoperability across the board. There's one last thing I wanted to share, and that is an IoT-related environment or demo as well. Let me find that window. This one. Okay, so when we heard the news that there are airplanes out there that just disappear from the sky, we figured that maybe we need to do a little test and a little experiment. And what we did was we got a quadcopter and we mounted a number of sensors on this quadcopter. Maybe the camera can take this. This is an Arduino-based the other one. So an Arduino-based set of devices that has a GPS sensor here. It has an accelerometer. It has a tilt and to detect tilt and pitch. It has humidity and temperature sensor. It has a digital compass as well. So we mounted this onto a quadcopter, and we wanted to see if this data can be sent over the web. Well, we wanted to make it as realistic as possible. We didn't have all the funds to get an airplane. So we wanted to put this, or have this communication over a satellite network. So we connected the quadcopter and the communication to a laptop on Earth, and then we connected the laptop to the web over a satellite connection. The satellite was one of the 11 geostationary satellites that Inmarsat is operating, orbiting at 22,000 kilometers. And we measured the latency. We flew the quadcopter in California, and we got our IP address from the British Telecom in the UK. And the latency it took to get from California over the satellite connection to London was around 650 milliseconds. And then we took that data and we distributed it out over the public web so that anybody could subscribe and see what the quadcopter was doing. And so this could be air traffic control in our case, or aircraft manufacturers, airlines, or the general public. And we measured this latency as well. This was about 350 milliseconds to the slowest corners of the web, to Namibia or Antarctica. So what you can say is that you can have all these sensors mounted on the tail of an airplane, and in less than a second, over the public web, over a satellite connection, sitting on Antarctica on your web-connected tablet, you can see that that airplane made a left turn. So let me show you what dashboard we built for this. This was a browser-based dashboard, but could have been anything really. It could have been a Java dashboard as well. And you can see this little box attached to the quadcopter as it takes off. In the middle, you see, or behind the background, you see the map. That was the GPS data. In the middle, you see the compass. You see the tilt and pitch information. On the left-hand side, you see speed. On the right-hand side, you see altitude. Bottom left is temperature. The video on the bottom right was recorded and edited into this just for demonstration purposes. It was not something that we transmitted. The size of the data that we transmitted was around 260, 270 bytes. We did all our math with encryption taken into consideration with 512 bytes. And these are the results we got. And again, the whole idea is that you can make these embedded devices, these Java desktop .NET applications, first-class citizens in a highly distributed world where the communication is happening over the web as if they were on the local network.
Is that you standing in the picture back there?
Yes, that's me on the left-hand side. Okay, so this is the, I think the last part. This is a selfie of the team that built this.
Video selfie, huh?
Yeah. Okay. So I think now I can hand it back to you.
Yeah, very cool.
Oh, actually, there was one more thing I wanted to show. Do we have time? How are we doing?
We have about 20 minutes, so let's see if we can get back to it
sounds good.
later. Yeah. So one of the questions people typically ask is, yeah, we saw all the fun stuff. WebSocket is powerful. All the devices, all the applications are good. I'm building a SOAP application. I'm building a REST application. How do I convince my management that it is actually worth it? So that's where I built a simple REST endpoint, a simple WebSocket echo endpoint. Both are echo endpoints, sending a bunch of data back to them and retrieving results from them. Okay. So if I go back here, I've pre-deployed the application already. This is how it looks like. So it says payload size, how many times you want to send. So let's say I increase the payload to say 100 bytes and to a REST and a WebSocket endpoint. Now the gray bars are supposed to be progress bars. They somehow are not working properly in this version of Chrome. They're supposed to be HTML5 progress bars, but maybe my code is messed up. But if I do echo, it says 10 messages of 100 bytes. Total execution time was 119 milliseconds. This is sending and getting the data back. And for WebSocket, it was about 13 seconds. Okay, so let's make this as 100 messages. All right, so echo it. Once again, 100 messages of 100 bytes, 265 milliseconds, 16 milliseconds. So not really visible, not really apparent to visual. Make it 1,000 messages. Okay. So now it's going to about 2 seconds. And this is still about 104 seconds. Let's make it a little bit more. So it's going to go longer. So remember what's happening with each REST is a new TCP connection that is being established and everything is done, all the HTTP header generation, processing, all of that is happening in the background. In case of WebSocket, you can maintain one connection and fire it and get the results back. So for 1,000, it's almost 8 seconds and this is still under half a second. So just to kind of compare and contrast, if you want to do that with REST and WebSocket, this is what you can try yourself. I'm looking for contributions, feedback on this particular benchmark. If this makes sense, if this is not the right thing to do, by all means, this is again one of the GitHub samples. So if you go here, so if you look on the GitHub here, this is WebSocket. This is WebSocket versus REST. This is a sample I just deployed on WildFly. So take a look at this. We're always looking for contributors. So send a pull request that this particular benchmark doesn't make sense, or this could be improved this way. We're always looking for contributions. Constant learning for us too. Then another question people ask all the time is, how does it compare with server-sent events? Now, server-sent events were introduced as part of HTML5 specification, which as of about 3 weeks ago is now a standard. So, this is one of those W3C unique standards which say they're going to go final in 2014, and they actually went final in 2014 after slipping for 3 years. But server-sent events. So WebSocket is a two-way bidirectional full duplex protocol. Server-sent events are server push. I don't care about sending any data from client to server, just getting pushed from the server. Stock ticker is a perfect example for that. Just like WebSocket, there is a JavaScript API, which is called as event source on the client side. So you just say new event source, you're listening to an endpoint, which is generating events using a particular MIME type. So that kind of maps very well to the REST endpoints paradigm. You have a REST endpoint, which is generating events using text/event stream media type. And on the client side, you have an event source API, where you're listening to that API and retrieving the results. So API is very similar to WebSocket. You say create a new event source, specify the URL. You have your state. You have your callback handlers. And of course, there is no way by which you can send any data from the client because it's a server push only. So how do WebSockets and server-sent event really compare with each other in that case? Well, server-sent event are over standard HTTP. It's just sending a particular media type over a HTTP connection. Once you have established a WebSocket protocol, you initiate using HTTP over TCP, but once upgraded, there is nothing HTTP about it. It's a completely custom protocol in that sense. WebSocket is full duplex. That means client and server can talk to each other independent, bidirectional. On the other case, server sent event is server push only. And if there is any negotiation or any data that needs to be sent from client to server, it has to be out of band using XHR or whatever mechanism you want to apply. In case of WebSocket, there is native support in most browsers, as you saw that caniuse.com website. There is no way by which you can polyfill that support, though. You can't say, oh, I can incorporate WebSocket support in IE 6, 7, and 8. That's not possible, although there are strategies to counter that. In case of server-sent event, there are ways by which you can provide third-party JavaScript libraries to polyfill that support. WebSocket is not a straightforward protocol. If you look at the framing API and all those things, it's a little bit involving, and you need a higher level API on top of it to actually get it functional, to be more productive. In case of server-sent event, it's pure, simple event source, listen to the events, that works very well. More details. In case of server-sent event, there is support for application reconnection or connection reconnection and event ID. In case of WebSocket, if you want to do reconnection, there is no such inbuilt support. So what you would do is you have your on-error or on-close callback handlers. In those callback handlers, you say, oh, connection is closed. Now let me reinitiate a connection or initiate a new connection. That's completely application-specific in that sense, although there are third-party libraries that facilitate that. In server-sent event, because it's done over HTTP, so there is no server or proxy change required. In case of WebSocket, we'll talk about it a little bit later, it may require proxy configurations. Server-sent event is text only. WebSocket is text and binary. We looked at that. In case of WebSocket, the message handlers are predefined, like callback handlers, on message, on open, on error, things like that. In case of your server-sent event, you have an on-message callback handler, but in addition, you can define custom event handlers as well, and even an event ID, which is not capability in there. So just some compare and contrasting server-sent event and WebSocket. Now, WebSocket is not a panacea where you say, oh, you know what, I'm going to solve world hunger with it. There are still issues with production going around it. We'll talk about it. One of the questions people ask again is, what makes them scalable, WebSocket scalable? Well, we saw how WebSocket does not require HTTP opening and closing connection for every message. That's the important part. So the handshake is done over a single TCP connection, and then the TCP connection you are holding on to, and you're doing unlimited message exchange between client and server. In contrast, if you look at Apache, which is the most popular HTTP server, there is a 5-second timeout for HTTP connections. So you have to reestablish the connection again. Other part is, in HTTP, we saw it's a very chatty protocol. There are a lot of headers that go back and forth, cookies, content type, all of that, all sort of issues come into there, which is not the case for WebSocket. It's a very lean protocol, and I'll talk about that lean part in a second. So what that gives is reduces your bandwidth dramatically. All those headers don't need to go over the wire in that case. WebSocket, lean protocol, very minimal data framing. This is a snapshot from Peter's book, actually. It talks about how the framing is being done. And literally there is 2 to 14 bytes total of overhead when you are sending data. And the amount of data that can be sent over the wire is potentially unlimited, or practically unlimited in that sense. Effectively, when you send a message, each message is mapped to a WebSocket frame, and each browser has different capabilities in terms of how big a frame could be. I've tried up to 1 gigabyte, and that seemed to work well, unless you are really packaging your 5 gigabyte of movie in one WebSocket message. You may hit some practical limits over there. But in terms of the data framing itself is pretty limited. You can see there are 2 bytes over here, which talks about the opcode, whether it's text, binary, control message, then how much is the length of the message. And if you have a much bigger size, then those bytes are reserved for extended length. Maintaining a TCP connection on a server is relatively inexpensive. It's basically pointing to one file descriptor. See, all the connection is happening over one particular port, 80 or 8080, whatever your port is. So it's not the matter of how many ports can be open. It's all a matter of how many file descriptors can be opened, which can further be tuned. And also on Linux, for example, potentially you can have up to 1 million file descriptors. On Undertow, we ran some internal benchmarks, and we were easily able to handle up to 60,000 concurrent connections without any tuning. And that's, again, out-of-the-box configuration. With WebSocket, again, a smaller data fragments can be sent without a request or a response. You just want to send a message, which is unlike HTTP, where any response or request that needs to be sent must be accompanied by the HTTP headers. All right. WebSockets scale vertically very well. If you want to add, we can easily set up load balancer. We saw Apache HTTP with a WS mod proxy, mod proxy WS balancer. HTTP servers are typically configured to log the entire HTTP request, which basically adds another twist for your performance reasons, which is not the case with WebSocket, at least for now. We saw how grandma and polling, you going yourself, is inefficient. WebSocket is definitely more elegant. You want to be cool. We talked about how number of concurrent clients really depends upon your file descriptor settings. All right, so let's talk about pretty much some of the last topics. How do we debug WebSockets? We talked about already Chrome developer tools. That's my primary way, and I think Peter is also looking at that extensively. How we debug WebSockets. Look at your headers, look at your frames, all of that information. Another thing that I want to show here is, so if I go to my browser now, I can go to Chrome Net Internals. Okay, I can look at, say, sockets here, and I can say show me view live sockets. So now, well, I don't have a connection established, but effectively if I go to, say, websocket.org, resolving host, okay, almost at the end of the presentation, and the wireless is not behaving. Am I connecting to the right network? Yeah. Okay, well, oh, there you go. I don't know what happened. Well, the idea is here you can see your live traffic. Well, I got a snapshot for that. So you can see what all sockets are live. So this automatically shows up here. You can select a particular socket that you want to watch, and it will show you more details about that. As the messages are being exchanged, this is again inbuilt functionality of Chrome itself. And then, if you want more details, then of course Wireshark is how you can start sniffing traffic at the network. So I have it up here. So this is my Wireshark interface, for example. It's a little bit complex interface, but if you want to just listen on loopback, so okay, I'm going to capture on loopback, and I'm going to start. Okay. So now I have my WildFly server running here. So if I go here, oh, no, okay. So if I go run on 8080 and I say chat, so that is connected. So if I go here, it's showing me all on the loop back, but I can say just show me HTTP traffic. So it shows me only HTTP traffic. So here you can see it's showing me my HTTP transfer protocol, all the headers that are being exchanged back and forth. Okay. But it's still not showing me my WebSocket headers. An older version of Wireshark used to show HTTP and WebSocket in the same window or in the same filter. They apparently fixed that recently. So now I can see only the WebSocket messages that are being exchanged. So if I look at it here, well, if I go to the browser first of all, and I say join, now you can see more WebSocket messages being exchanged. So here is my client message. So here it says, I have to, well, on the client, the way protocol works is from the client to server, all messages are masked. In Wireshark, you can say unmask the message, in which case it's showing you Duke joined over here. And from the server, you can see the response that is coming back. So you can literally dig down to TCP, IP, and all of those complete details, complete dump of what's going over the wire. All right, pretty much the last few slides. Proxy can be an evil for WebSockets. That's like something which is very common. For example, the proxy can look at your upgrade header and they can remove it. Well, how do you know whether the connection has gone through in that case? So what you do is, in your when you are setting a WebSocket connection, you set a timeout. And once you have connection is open, in on open, you remove that timeout. So that way it makes sure that, okay, in 3 seconds if the connection is not done, that means it's not open. If it's done, then you just remove that timeout. So that's one way you can fix it. The other thing is the TCP connections can be closed if they're idle for a certain amount of time, say 5 seconds or 10 seconds, whatever your proxy setting is. In that case, you need to build an application level heartbeat. That means you do ping pong at the application level, which is very important. In certain cases, proxies could be strict that, okay, these are the only HTTP headers that are allowed, anything else is not allowed to pass through. And that's where you fall back actually on your grandma story. Say, hey, you know what, grandma, my WebSocket is not working, my mailman is sick today, why don't you go hang out at the post office now? Load balancer, we saw examples of that, but the tricky part over there is the Amazon Elastic load balancer doesn't work with WebSocket. So you need to really configure it for TCP level load balancing in that case. But in that case, let's say the same load balancer is used for WebSocket and HTTP. But if you configure it for TCP level load balancing, you'll use HTTP session affinity. So there are still some issues around, how to take it into production deployment. In terms of browsers, we looked at how IE 6, 7, 8, 9 and Safari 5 don't support WebSockets, in which case you fall back to libraries like Atmosphere or Socket.io, depending upon your framework of your choice. Because these libraries, what they do is, Atmosphere particularly, I'll talk about in a second. With Atmosphere, you can say, try to make a connection. You can specify the transports it can try to. So by default, it'll try WebSocket. If WebSocket is not supported, it'll fall back to long polling automatically. And then whenever your server or proxy or somewhere in the network that thing is enabled, it'll start using WebSocket automatically. So that's sort of the advantage of using these third-party libraries. And then there are some inconsistencies in GSR 356. Now, Java EE 7 has been live for a year plus, actually a year and a half, but there are still no production deployment servers yet. WildFly is available, that's community version. Glassfish is only reference implementation. Tmexsoft is kind of a shaky implementation. There is nothing that you can buy commercial support on. So JBoss EAP, WebLogic, WebSphere, those are all in the pipeline. But again, how do you bring that out live? I think I'll skip this introduction to Atmosphere. All the material, as I said, are available on github.com on my Git repo. The slides are already posted over there. A PDF version of the slides are already live there. So by all means, use that. And I'm going to switch to browser. I think there were some questions that were still pending. Well, not some, apparently 25. Okay, Peter, come on in, buddy. Okay, here you go. Can I have a book? Okay, after that. C10K problem is about optimizing network sockets to handle a large number of clients at the same time, 10,000 connections. This is referring to the same question that we had earlier. Well, with Undertow, as I said, we were able to handle 60,000 concurrent connections very easily. Didn't see any issue.
Yeah, I can give an example. There is a car racing franchise in the US called NASCAR, where they are making left turns and left turns only, the drivers. They have a second screen application that allows viewers to have a virtual 3D rendering of the race. There are between 100 and anything north of 100,000 concurrent clients who are following the race. And our experience shows that in a production live deployment of this, there are more than 20,000 concurrent connections that can be served by I think medium or medium-large Amazon instance. So I think that 60,000 connections, that is a good number.
Yeah. Most of the time, if you are having a bottleneck, it typically would be in the application itself rather than in the infrastructure. But yeah, it's good to be aware of both the sides of it.
Right. But I'm happy to take this question back to our engineering team if you want to find out or learn more about it. So come to us, talk to us, and I'm happy to.
And there are 3 tweets that I see. Antanas, Vladimir, and Alex, you can come pick your book. Will there be a WebSocket server in the JDK? We have HTTP for now. So there is apparently a JEP that I saw, Java Enhancement Process, to have WebSocket server added to JDK. So stay tuned on that. The comment is nice and all, but it's nice enough for a book. Okay, it's nice enough. Artigo Land, you can come pick up your book. That's 4 books gone already. Is it 1 socket per client? 1 socket per client. So if I want 100K clients on one machine, I use 2 network devices.
2 network devices. I'm not sure I understand that part. But yes, typically you would have 1 WebSocket connection. There's nothing that would stop you from having multiple WebSocket connections or multiple WebSocket connections to different servers as well. But typically 1 WebSocket connection per application to 1 server. That is the...
yeah, which is important to understand, because typically if you're using polling or long polling, then browsers created those artificial limitations where you can have 2 connections from the same domain, or in some cases up to 6 and 8. That's not a limitation really with WebSocket. I can have 7 tabs and all connected to the same backend, for example. Who's doing nuts and bolts? That is us. Are there plans to enhance the HTTP server in the JDK to support WebSockets? I think that should be covered as part of the JEP that we talked about earlier. Just demoed abuse of tests. Oh, sorry, no, this is only demo environment. Please don't do that in production. Undertow versus Tomcat. Yeah, well, that's more like that's not a WebSocket question by itself. The reason was very clear why in the Red Hat we picked up Undertow as a brand new initiative, because Tomcat wasn't scaling up to the level where we wanted it to. With Undertow, we saw you million concurrent connections for 30 seconds straight. That worked very well for us. That's a question repeat. Very informative code living session. We love doing that. Really interesting session. Picture.
Ooh, bunch of people.
Nice interaction. Yeah, we like people. Yeah, nice interaction between browser and iPad. Really demo. Nice online checkout demo. Cool. Example, WebSocket versus what would you like when REST would use keep alive? See, keep alive is more HTTP level functionality. That's not something that an application can rely upon. So I think that's the important part to understand. With WebSocket, you can actually rely upon application fundamentals to make that communication. So by all means, Daniel, feel free to send me a request, pull request, try out these. We love hearing that. Probably using persistent connection with REST will boost the performance since it uses the same TCP connection. So I don't know if the persistent connection is really honored throughout the layer itself. With WebSocket, that is a requirement. Yeah, I think that's the big difference that I see. Is WebFrame kept in memory or is cached on disk for WildFly impl? Now, well, first of all, from the browser side, when you make a request, you say send. It's not sent right away. It depends upon your network stack and the underlying operating system and the browser implementation. And then on the WildFly side, again, the same thing happens. So from there, you hand it over to JDK, say, hey, JDK, just send it out. And remember, in the WebSocket JavaScript API, we talked about the memory buffer size. You can also configure that to define how much you want to retain in the buffer before it's actually sent out on the network. That's sort of one way to control the configuration. Maybe I need the book. So I think Jan C, if I'm pronouncing it correctly, that's probably the 5th book in that case. Okay, I'm glad you guys like the talk. How do I avoid running out of ports on the server? Remember, we said WebSocket is not about ports. It's about the file descriptor, so you don't need to worry about ports. It's still running as a socket on the web. That's the important part you want to understand. Any closing comments, Peter?
Well, I guess we have seen some pretty impressive technologies here. We look forward to more adoption. This is something that would definitely have to come from you guys. We are very interested in your further comments and, more importantly, the ideas and thoughts and contributions to everything that Arun has put together and what you have seen today. Thank you very much for coming.
Excellent. Thank you very much.